Phones are on the silent mode. This is to maintain the decorum of the seminar, the meeting that we are about to begin. May I please request everyone to be seated as soon as possible. Thank you.
एक सेकंड में बस हाँ एक खाली कॉपी कर लूँ डाटा बस लेट डाटा दिया ना कहाँ गया जी
May I please request everyone to be seated. We're about to begin. Ladies and gentlemen, may I please request everyone to be seated. We can still see some of our participants who are entering and standing near the entrance. May I please invite everyone, request everyone to be seated. We're about to begin. सभी से निवेदन है कि जितने लोग खड़े हैं आप प्लीज़ बैठे. हम आज की इस गतिविधि को सेकेंड डे ऑफ ग्लोबल हेवी हॉल सेमिनार 2025 की शुरुआत करने जा रहे हैं. A very good morning to all distinguished delegates and guests. After a truly enriching and insightful day one, where we explored cutting-edge innovations and shared invaluable perspectives. We are delighted to welcome you back for the second day of the Global Heavy Haul Seminar 2025. Today promises yet another series of engaging sessions and thought-provoking discussions. Incidentally, today also marks the International Yoga Day, a global celebration of balance, focus, and inner strength, the qualities that resonate deeply with the precision and resilience required in heavy haul operations. With that spirit of clarity and harmony, let's begin today's sessions with renewed energy and purpose. But before we do so, we will take a look at a very special video on the remarkable work being done by the dedicated freight corridor, a key driver of efficiency and transformation in freight movement across the country. Let's take a look.
The Dedicated Freight Corridor Corporation is fueling India's cargo revolution, moving freight with unmatched speed, precision and purpose.
ईस्टर्न और वेस्टर्न कॉरिडोर, डेडिकेटेड फ्रेट कॉरिडोर जब तैयार हो जाएगा तो मालगाड़ी की स्पीड भी बढ़ेगी और पैसेंजर ट्रेनों में होने वाली देरी भी कम होगी।
DFCCIL's masterpiece, the Dedicated Freight Corridor, is India's largest rail infrastructure project transforming the future of freight transport. For decades, India faced a tough choice: prioritize passenger trains or freight. With both sharing the same tracks, delays were inevitable, costs surged, and efficiency suffered. Even though freight trains generated 67% of railway revenue, while passenger trains accounted for just 33%. The Dedicated Freight Corridor is the answer. Spanning 3,000 kilometers, it's designed for long, heavy haul trains, boosting capacity and slashing turnaround times. A first for Indian Railways on a fully electrified network. With double stack trains for higher loads and long haul trains carrying over 100 wagons, 10,000 tons in one trip. Efficiency reaches new heights.
Dedicated Freight Corridor is one of the iconic projects conceived post-independence. Western Dedicated Freight Corridor starts from Dadri and runs right up to JNPT. Eastern Dedicated Freight Corridor starts from Ludhiana and goes right up to Solnagar. After the commissioning of the whole section, that is 100% commissioning, our potential, our total utilization of this dedicated freight corridor will reach to its maximum.
High-speed, high-volume freight demands smarter maintenance. Instead of reaching to failures, DFCCIL predicts them using trackside sensors, AI analytics and real-time monitoring to keep the corridor safe, sustainable and reliable. An automatic signaling system optimizes train flow, while the 2x25 kilowatt power system supports heavier loads. Wheel impact load detectors spot faulty wheels early, preventing rail damage and ensuring smooth operations. Smart features include load vibration and temperature sensor to detect rail stress, acoustic sensors that hear faults before they are visible, AI models analyzing data in real time, sending precise alerts to crews. DFCCIL's tech-driven approach includes hot box detectors to prevent axle failures, machine vision systems for automated defect detection, automatic fault locators for quick repairs in overhead equipment. Track recording cars use sensors to inspect tracks, instantly spotting wear, misalignment, or irregularities. This data keeps the track in perfect shape, ensuring safety and efficiency. The dedicated freight corridor is more than structure and speed. It's the backbone of India's economic growth. By connecting industries, empowering businesses, and moving the nation forward, DFCCIL is not just building tracks, it's building the future. As India strides towards Viksit Bharat 2047, the dedicated freight corridor stands as a testament to our ambition, strong, smart, and unstoppable. The journey has begun. The destination, a brighter, bolder India.
Absolutely wonderful. After that amazing video that we saw, ladies and gentlemen, we'll quickly dive into the proceedings of the first technical session for today on the topic of Built to Last, Interface Design, Precision Welding and Fleet Intelligence. This session will spotlight innovations at the rail sleeper interface, the role of precision welding and the engineering intelligence that supports long-term durability in heavy haul environments. Our speakers bring expertise from welding automation to under sleeper pads and sleeper level data analysis. To moderate this discussion, I request Shri Vijay Sharmaji, an expert in track systems and high performance infrastructure. Sir, we look forward to your leadership in taking this session forward. Over to you, please.
Thank you. Good morning. Senior management of Dedicated Freight Corridor, Railway Board and Railway officers, all the authors and speakers, delegates. I welcome you all on day 2 in the morning's technical session, Built to Last, Interface Design, Precision Welding and Fleet Intelligence. As we know, the DFCCIL has already commissioned and it is time to have the maintenance system so that we get the better performance, sustainable performance and the life cycle cost is reasonable. Today we have 4 speakers. Let me introduce all the 4 speakers. Mr. Juan Lazcano, he is Business Development Manager, Penroll Sustainable Resilient System. Mr. Lazcano will discuss how under sleeper pads and embedded track systems are reducing maintenance requirement and improving track longevity across heavy haul corridors. His insights will highlight performance in benchmarking and life cycle cost saving achieved through optimized track interface design. Mr. Benjamin Hennis is the Director of Business Strategy, Holland LP USA. Mr. Haynes will present innovations in mobile flash butt welding with a focus on neutral temperature management, defect remediation, and closure welds. His presentation will offer examples of how precision welding improves safety, reduces unanchored length, and speeds up commissioning, especially relevant for high tonnage corridors like DFCCIL. Mr. Rafael Marotta is the Segment Manager, Heavy Haul, Austria. Mr. Marotta will speak about track superstructure resilience, focusing on elasticity, vibration isolation, and ballast protection. His work on elastic elements is crucial for reducing dynamic stress on the track and optimizing geometry retention over time. And Mr. Anmol Kaul, he is the Senior Product Manager, Track Machines, connected to India. Mr. Kaul will round off the sessions by showcasing how fleet-based diagnostic, condition monitoring, and data intelligence are enabling smarter maintenance planning and rolling stock utilization in the Indian context. We have about 20 minutes for each speaker, and I will request if there is any question or a doubt, please raise your hand, write on a piece of paper. The volunteers will collect the paper, and please volunteers give these questions and queries to me. Thank you. Now let us begin with Mr. Juan Lazcano. Thank you.
Good morning, everyone. I would like to say, first of all, what a great pleasure is for me to be here. Back in India, where I have spent some of my best years personally and professionally, being back at Delhi always warms my heart, and I'm humble for this invitation. I only hope that you find some of the topics we are going to discuss and share of our experience are relevant, and we can have a fantastic session also with my fellow speakers. So thank you again for this kind invitation. So today, the session is going to be focused on critical aspects of our technology linked with the heavy haul pain points and requirements. Let me try. Okay. So I'm coming here as Penroll, where you can see we are a global company. We are partnered with main networks around the world. And to summarize our vision, our aspiration is to contribute to the main objectives of networks around the world, looking at availability, safety, and be more than a supplier, an engineering partner. Our presence allows us, at the end, to share experience globally. When we look at Pandrol, we have several core business focused on fastenings and weldings, but there is this knowledge built around the track has also some branches of this tree that lead to the specific systems we are going to discuss today, focus on the track resilience. One of the associated divisions that I personally I'm more involved in Pandrol, it's everything around track resilience. We believe that more and more track resilience is a way to reduce the life cycle cost, prolong the life of the track, and this knowledge of Pandrol going up in the track and fastenings, weldings, and our return of our valued customers is bringing this specific know-how of seeing the track as a whole. It's crucial on track design not to look at one side of the story, but understand how all the components are interacting. And this is what we can share with confidence, and we believe is the value of our company. So when you think about what we can offer to fantastic projects and high demanding assets like a heavy haul infrastructure, we need to briefly look at our resilient solutions, and also you can check in our stand condition equipment focus on the stress-free temperature, like you see in the picture, but in my focus today will be on the ballasted track mostly, plus a not so recurrent and maybe different quick angle on how an embedded rail solution, it's also a very good idea for a heavy haul. Again, the keywords are going to be resilience, track design, and optimize the track stiffness in a way that it really reduces the life cycle cost. So the first stop is under slipper pads, which the best way to show it is graphically. What is the concept here? We are looking at basically placing an elastic element under the slipper. This additional layer of resilience is going to be key for performance. There is one root cause for many of the discussions that fantastic discussions we are having here today, which is we are talking about track infrastructure, which is basically getting hit by a huge dynamic loading. These forces are affecting and degrading and impacting all the elements of the track. So this is the core issue. And this is something that when you place this elastic element, you are directly influencing positively the load distribution. Again, when we think about the 400 kilonewton load axle, without USP, what happens when the rail impacts, and you can see this graphically to mark my words, that particular slipper, the load distribution, it's really focused on a reduced number of slippers. So you have a very high impact on, let's say, 1, 2, 3 slippers. When you actually help and increase the resilience, this load distribution enhances, and that peak stress that the rail seat is suffering gets really relief, and it's better distributed. Only that principle marks a huge difference that we need to take into account. The working principle here is very linked, as we saw in the previous slide, with the working elastic length, right? We want that the track have increased the working elastic length. So again, all the elements in interaction, we have seen first the level at the rail seat of the impact of the rail, but then let's see what happens below. And this is a critical aspect of resilient element like under slipper pads, is to increase the contact area with the ballast. Ballast degradation and therefore maintenance and tamping are the consequence of these dynamic loadings impacting and making all the stones fly. When we break it down to the single point of the technology, that it's measured constantly, and today specialized companies are putting this at the core of the discussion in the technical standards and norms. The key here is to look at the contact area. Without this resilient element, the stones of the ballast are having a minimum contact pressure. It's a very sharp stone that is going to be contacting just this 4-8% typically that we see. But when you add this extra resilience, you see that the embedment of the ballast is much more significant. Therefore, the contact pressure is going to be reduced. This is also going to be, this is going to facilitate a much more positive behavior of the ballast, and then therefore reducing the ballast attrition, degradation, all the side benefits are coming from this better track quality, ballast quality. A way to measure this, that it's being more and more adopted by networks around the world who are using this type of technology, it's simply to take a look. We use, there are different tests available, but one quick way is to simply, by using of chalk and then scan it, see where the imprint of the ballast is. And this is where the different numbers that today are around contact area are coming. But everyone, there is an agreement, an overall agreement of a 20 to 40% contact area, in many cases, depending also on the stiffness and elasticity of the USP. Let's go quickly to the main benefits. When we look at under slipper pads and a resilient element, it's going to help in the reduction of maintenance. For sure, being an element of an elastic element, it can help in very critical areas, bridges or tunnels. These critical areas where there is a need to reduce the ballast layer of thickness, it can be a way to compensate and really control the overall track stiffness by substituting this ballast, which is, let's remember, is also an elastic element of the track. Transitions on design, we're going to take a look later, and noise and vibration attenuation, which is also possible also in heavy haul when you are nearby urban areas. It's also a need, maybe not primarily, but again, for critical sections, it's something to take into consideration, because at the end, these technologies, let's say they are relatively new in railway terms, 25, 30 years, so relatively new. A railway is a world of facts, accumulation, proven track records, but it's also already, after 30 years of the first references that in our case were in Belgium and else, there is a state-of-the-art position and very well-developed norms and case study with specialist companies like we are present here today. There is like a foundation of everything that we do, which is a fantastic report of International Union of Railways and USP, that after several test tracks, they throw and they establish the frame of the first positive values and benefits. This is, so these numbers that you see there are coming from that report. A lot of focus on European countries with very difficult sections like Switzerland, Germany, where today we see the majority of the adoption. But at the same time, in the last 10 years, there's been an acceleration, also spearheaded by heavy haul on the adoption of these systems, because they have seen even better values than what you see there in terms of reduction of tamping, track geometry degradation, and track quality overall. It's difficult to summarize and put values because this is a very network experience case. So I think case studies are much more interesting, and it's not about fixing one number. It's about understanding every track and network needs to define the right USP. It's the best approach. One of the foundation stones was this SBB Switzerland case, where here basically what we see is a very specific, the challenge here was to really find the right stiffness for the needs of the network. This is where you can see the difference between using USP, in this case it was an intermediate stiffness, versus sections without USP and the increase in track settlement. We have networks like in the case of Belgium, they have been using this technology 30 years now. And it's a recurrent, it's not for critical section, they use it recurrently because they see an accumulated benefit in maintenance reduction. And also a positive impact on corrugation, which is, again, the most valuable data is always with the networks, and this is also where we want to always to be close to learn, and that's the best empirical way to approach this technology. But as you can see, from Belgium, these cases we are going to see is Belgium, Sweden, and US. Every pain point of the network can be addressed by having this overall view on the track. Again, our approach from Pandrol is stiffness in the fastenings, what happens in the welding and below the underslipper pad. We see the track as a whole. So when we look at Belgium, the focus is on track quality. In the case of Sweden, traffic Berket, they are more associated with freight and heavy haul because there were some needs of, they're using this technology for the mining lines. Also, they were looking for long-term track protection. In the case of Amtrak, in some critical areas, they saw a fantastic number of factor 6 reduction of tamping. And today, I think in US, they are the most adopting, by far, they are the pioneers of adopting this technology. Australia, cases focus on ballast protection and this transition stiffness problem they have on bridges. There is one case in Brazil also that we know that it's clear from IHHA also that the freight in Brazil and MRS, Rumo Valley, they have been really the pioneers of this adoption for heavy haul, and it's one of the best references that this technology can have. Today, the state of the market is telling us quite clear that the market is demanding track experts who are capable of understanding sustainability of the track in the sense of prolonging the lifetime, in the sense of being as green as possible. But again, after 30 years, there are some initial conclusions. It's widely recognized by International Union of Railways and the norm, the European norm of underslipper pads, that there are several elastomers that can be used. Today we see a trend that is mostly focusing on the best performing, which are typically the polyurethane and the rubber-based solutions. In our case, we also use rubber for our technology. This is a way to achieve the purpose of the elastomer, which has to be, and it's especially important of heavy haul, proven resistant. It really has to have an excellent performance in fatigue. So this is one of the reasons that we are using this material. But again, it's about the system and the knowledge. There are many different materials to achieve, and it's about your capability of testing and the hard facts after 30 years of how this system performs. So for that, and this is a recommendation in general that we give by Pandrol, of course, there is a state-of-the-art norm who prescribes the necessary testing for the stiffness, to how to measure the fatigue. But at the end of the day, if I need to choose one, I will always focus on one specific test for fatigue and really durability, which is the one that we needed to pass to get homologation in SNCF in France, which is the Vibrogear. Why we always recommend this testing? Because it's the most conclusive and powerful way to really try to simulate the torture, because I don't have any other word, the torture that this slipper kid with underslipper pad is going to suffer during their lifetime. So this particular test, developed by SNCF and now accommodated in the EN standard, is, I would say, is a must for adoption and being sure that this system is going to pass the test of time. The result you see there is basically, you see the setup, the slipper is equipped with the vibration. The idea is to simulate up to 1,000 megagross tons and see the variations, both physicals and in terms of stiffness, to see how the material has been given the performance throughout the lifetime. A very quick point, because I'm going to check quickly. Okay. Very quick point on some investigations we are leading today. The group of engineers of Pandrol is also part of the CEN committee, which is the committee in charge of redacting, updating, and taking care of the EN standard. It's formed by specialized engineering companies and suppliers, and also the networks of European networks are present there. So one of the challenges we see today, and I think this is a general problem, is we need to simplify reality on labs to understand how the system works, but sometimes we need to keep a good push to make sure that the conditions of the lab are representative of what happens in the track. So there was a very particular case, there is a very particular discussion now related with stiffness, and we led a push and an investigation for changing the way stiffness used to be measured with the geometrical ballast plate, and trying to go to a more setup like the one you see below, one that is more representative. Because when you go with that GBP, which is an ideal composition of the ballast, you are not really working in conditions, therefore the stiffness can be under measure. So this is just an idea of the necessary push and investigation that is always behind. And again, we are getting more empirical, more case study, even lab conditions, they need to be closer to the track. That's the way to really have solid data that enable a solid forecast on how the systems are going to behave and really get in control of your life cycle costing. Brief recap until now. Again, 30 years technology, well-proven track record, different solutions, International Union of Railways Foundation, and a leading norm, which is the European norm, and very good feedback from customers around the world. Today, we are also trying to develop a different approach with some of our customers where we really need to think like an asset manager, and for that, we have briefly, this is going to be just 10 seconds, but there is this tool that we can also sit down with our customers to bespoke and understand, by after defining a USP, what is going to be the impact in the long term and the return on investment of introducing in terms of damping and savings in the long run. Again, this is a sophistication, but it's needed because today we are going to this smart asset management, and this is a technology that can contribute. And essentially, today, I am really taking your time to talk about resilience, track resilience. Track resilience means more longevity. And in this sense, a very similar working principle, but with different application, is under ballast match, which in this case is going to increase the elasticity of the track. Of course, logically, again, we are in track resilience with a better distribution of forces. And it's also going to help the overall substructure and structure of the track, but in this case, by placing the mats below the ballast. This track protection is different, and we recommend this probably for cases more linked with transitions and noise and vibration, because it's more cost effective, and it can be also combined with USP. At the end, it's about track design, facing each case with the necessary ad hoc approach. It has to be bespoke, but typically what we see the use of under ballast mats is in this design of transition zones. All the elements of the track are going to suffer because of this jump in stiffness, logically. The dynamic loading is going to impact unless you create a much more controlled deflection. And for that, you just simply need to prepare a little analysis where you replace and you control the elasticity by putting the under ballast mat, and you keep it always well under control. We always typically recommend, like the International Union of Railways, always to keep this 0.5 millimeters in this differential deflection. This is a side benefit also linked with elasticity is going to be noise and vibration, and essentially an under ballast mat is going to decouple the ballasted track from the surroundings. There are many cases that we see where by the expansion of networks, residential areas, hospital, universities are very close to the track, and this ground-borne vibration needs to be tackled. So the most effective way is to place an under ballast mat and keep the structure isolated. So as you can see, different networks, they speak for this technology, and they use it for this track protection, this reduced ballast thickness, the case of Belgium. More heavy haul relevant will be the case of Etihad Rail in Emirates, where for several years now, more than 10, they use it recurrently for ballast and substructure protection and track quality improvement overall. Also in Spain, there's a very typical combination of under ballast mat for high speeds when it comes to in some tunnels and when they are entering urban areas, especially on the high speed connection. So it's a very typical approach that their engineering team prescribe normally. This last part is not so obvious at the beginning when we look at ERS for heavy haul, but it's something that we see as a market trend growing more and more for the slab track parts. We need to look at some parts of the application of here. In this case, is going to be linked with these stations, depots, and ports, where you really need also to look at the track quality from this point of view. And this is an excellent idea because a continuously supported track is going to facilitate, in the case of depot, it's going to facilitate the operations. It's a system that is built to last. So for some critical sections, and we will see examples in a second, it has been proven as a fantastic choice. At the end, the concept is clear. You are going to encapsulate the rail. There are no slippers of tire. This whole setup is in itself a fastening system and is tested according to a fastening system. And the technical advantage here when it comes to track quality is quite simple. Versus a discrete resilient support, you develop a continuous resilient support. So as you can see, this differential deflection does not exist. The slab track, it's built to last. The whole idea and the whole point of this ERS is to get it maintenance-free. Because the elastic rail deflection does not happen. So you have, the track is going to be controlled longitudinally, vertically, and laterally. By doing that, again, we are looking here at specific critical areas. By doing that, even in the case of braking, which is logically very rare, but even in that case, that continuous loading, that anchor is going to reduce even the gaps. I'll give you an example. When we had this system is installed in Portugal, in Lisbon, and even when there was a couple of rail breaks, but it was so minimum that the train was still in operation. So this is always due to the continuous, the control and the absence of differential deflection in the rail. This elastic deflection doesn't happen. So as you can see, field of applications are going to be depots, freight facilities. I think I see an alarm here, so I'm going to recap. We're talking about freight heavy haul in depots, in freight facilities, and a very interesting, I think is very relevant. For intermodal ports, we see more and more that rail connection is going with embedded rail. Again, it's clean, it's maintenance-free, and it allows machines and operations. Almost right on time. I almost made it. I'm proud of myself, almost. So, conclusions. USP, UBM, and ERS are focused on track quality. Resilience is the key. These systems have to resist the pass of time, and they are enabling freight and heavy haul today to maintain their targets in terms of availability, safety, and overall track quality. This is our value proposition. This is the experience we can share. I can only say thank you again, and I'm really hoping that there are some questions that make that, and even if they are difficult, these are the type of questions I like. So thank you very much for your time.
Thank you. Now, we have second speaker, Mr. Benjamin Hennis. And if there are any doubts and questions, please send it to me. Thank you.
Thank you very much. Firstly, I'd like to thank the dedicated Freight Corridor Corporation for having us here today. It is a real honour to be invited to present, and it's been a fantastic event so far. There's been some amazing presentations, both yesterday and already this morning, and I look forward to listening to the rest today. Well, somehow we've gone on to... All right. The topic of discussion today will be rail infrastructure resilience, an integrated approach to defect remediation and neutral rail temperature management via flash butt welding. So my name's Benjamin Haynes, and I'm the Director of Business Strategy and Development for Holland LP. I've been involved in the rail industry for 14 years, and I specialise in the strategic delivery of rail infrastructure projects. Throughout my career, I've worked on new construction and maintenance of some of the heaviest haul rail networks in the world. One of the strategies has been the implementation of flash butt welding and its integration into rail maintenance practices for both track stability and weld quality. So who are we as Holland? We are a rail technology and manufacturing company that delivers multidisciplinary contracting services. With over 50 years of experience in delivering flash butt welding services, we have the largest mobile fleet of flash butt welders in the world. We also design, build, refurbish and operate fixed welding facilities and their infrastructure for a number of our clients around the world. As a rail technology company, we also have other divisions within our business, including our RMSS division, which has over 30 years of track geometry experience, utilising such equipment as our portable system, Argus 2.0, which you'll see in the photo, our UGMS locomotive mounted system, and also our specialist testing vehicles and products. In the last couple of years, we've been very happy to introduce what we call the HAMMER system, the Holland Automated Manganese Repair System, designed to repair manganese componentry and rail crossings. So in terms of a global footprint, our business has over 900 team members, all acting towards the same goal, to listen to our customers. As I mentioned, we have the largest global fleet of over 180 mobile welders, of which 3 are battery powered. It's a really exciting technology for us and goes into our core value of innovation, where we're looking for a more pure source of power that allows us to have greater finite control of weld inputs. It also allows us to help our customers reach their targets of reducing their carbon footprint. In terms of a global presence, we have equipment in over 40 countries. So we have a very good understanding of different rail markets, but also how that we can efficiently collaborate across industry to provide the most effective solution. In 2024, we produced over 242,000 flash butt welds and tested over 500,000 kilometres of track. I say that because it's a testament to the scale of our business, but also the data that we can collect. So key topics to be discussed today. Neutral rail temperature and just defining that. Rail axial thermal forces, the cause and effect of incorrect rail stresses on rail infrastructure, and corrective measures through advanced flush butt welding technology such as ours. I'll also provide a case study of an example of how we've used our modern equipment to service our clients and adjust their rail stresses. So neutral rail temperature. The neutral rail temperature serves as the baseline reference for managing axial thermal forces. It is a functional benchmark defined by design and altered through rail maintenance. It indicates the temperature at which a rail segment is free from internal longitudinal stresses. At its core, at NRT, the rail is in an equilibrium state, neither under compression or tension. Now, determining the NRT is usually done by the rail infrastructure manager and is based on the geographical region in which that rail segment sits. It's important to note that any particular network may have a number of different NRTs because of the geographical location. Now, there are multiple methods for determining the desired NRT, some of which are to the screen on the right. They are a guide that finds the best equilibrium for thermal forces within the track infrastructure, one that mitigates both the risk of track buckling and rail breaks. It's important to note that rail temperature must be recorded using reliable methods, such as calibrated magnetised temperature gauges and taken on the shaded side of the rail. So understanding rail axial thermal forces in continuously welded rail. Continuously welded rail is now the most commonly used form of rail construction. It has eliminated rail expansion joints, but that in itself has also introduced challenges. It is designed to improve ride quality, reduce maintenance, and extend the overall life of the asset. Now, as we know, rail is made of steel, so it naturally expands when heated and naturally contracts when cooled. Now, this would normally result in a measurable change of length in an unrestrained environment. But as we talk about CWR, we know that it is in a restrained environment and therefore introduces internal forces. So these forces are known as rail axial thermal forces. They are a critical engineering challenge, essentially thermal expansion and contraction in CWR in a restrained system. So what that means is the rail will experience compressive forces when the temperature of the rail is above the desired NRT, and it will experience tensile forces during temperatures below it. So what this can result in is a very large magnitude of rail axial thermal forces generated due to extreme lengths of the CWR, but also the rail stiffness itself. Merely a few degrees Celsius can generate tons of longitudinal force in any particular rail segment. Now, these forces don't just dissipate over time. They remain stored until released through physical intervention, such as cutting, de-stressing, and correct welding. Now, improper handling of these rail axial thermal forces can lead to severe risks, such as buckling when in compression, especially on curves. An example of that is the picture to the right, or fractures and breaks when in a tensive state, as the picture on the left indicates. Now, it's important that forces must be managed through stress-aware design, installation practices, and also validated welding procedures. So, cause and effect of incorrect rail stresses. The failure to establish and preserve the correct rail NRT can compromise the ultimate integrity of the CWR. This in turn leads to long-term operational hazards. Now, a big cause of this is welding and rail replacement activities, often performed at the incorrect rail temperatures, whereby the incorrect equipment is used that has the ability to apply a mechanical adjustment. An example of this would be such as closure welding below an NRT, significantly below the NRT, I should say. Completed without the correct equipment and without applying a compensatory action, such as removing steel and applying a controlled rail pull, will result in locking in future compressive states as the rail temperature rises. This in turn increases the likelihood of future rail buckles under the hotter temperature and dynamic loading of rail vehicles. Emergency repairs are also another example that can cause stress in the track. Due to the nature of emergency repairs, stress restoration is often overlooked. Rail teams often lack the capable technology that allows them to apply thermal stress adjustment, as well as procedural knowledge. Without reliable systems to measure, control, and restore correct forces in rail, this can also result in welds being compromised from the very outset. It is important that teams require the equipment with tensive capability, such as Holland's puller light, but also the operational understanding to apply this technology to fundamentals of track. We must also understand rail stress, and it's important in the longevity of rail infrastructure. Now, rail stress through adjustment campaigns is another time where rail stresses can unfortunately not be corrected. It is important that correct procedures are used to adjust the rail desired NRT, and that rail infrastructure managers clearly indicate how they wish to manage this. Approved methods must be able to be verified, including with intelligent technology such as Holland's IntelliWeld system. It is confirmation of equalisation of rail stresses throughout a rail module that are imperative to know that the works we're doing restore thermal stresses to where they need to be. Once again, correct equipment with repeatability and transparent reporting is of the utmost importance. And you can see there that is a picture of some of our technology, the puller light, whereby we're measuring the rail gap and also using a reference point system to measure a post tense. Now, something that's often forgotten is weld quality when it comes to stress management. Weld quality is vital to the effectiveness of rail stress restoration. A closure weld must be able to withstand the full magnitude of longitudinal forces that are applied. Failure to replicate the mechanical strength and ductility of the parent rail results in the first point of failure under thermal forces. If we think about CWR, welds are often the weakest part of the rail, and there are a number of welds within any network. Now, if I was to look at the number of welds that Holland do, over 1 million welds, we would log a non-conformance report of only 100 of those. That is an impressive stat that has not just come by luck, but with over 50 years of experience. What that means is that we are pushing to almost a 6 sigma rate in weld quality. something that we are very proud to stand behind. Now, when we talk about weld quality and weld breaks, failures are sudden and they're often catastrophic. They can lead to derailments, emergency speed restrictions, but also very costly reactive maintenance. Ultimately, poor rail stress maintenance leads to buckles and breaks. Now, of note, from studies that we've conducted, it takes significantly less force for a rail to buckle than to break, with approximately 818 kilonewtons of compressive force for a rail to buckle versus, say, 1,523 kilonewtons of tensile force for a rail to break. This, of course, has a number of other determining factors in regard to the rail infrastructure itself, such as ballast quality, sleeper selection, and any other forces in play. But ultimately, poor management leads to significant safety, operational, and economic consequences. So corrective measures through advanced flash butt welding technology. And it's important to note that this has come about through direct partnerships with our customers. Ultimately, Holland sets the benchmark in rail stress management through purpose-built equipment. Two key parts of our equipment is the IntelliWeld operating system, which we originally designed in 2015 and then once again improved in 2018, and so we're now running the 2.0 system, and the puller light. So the IntelliWeld system is that silver box that you can see in the top picture, and the puller light is that yellow frame. When we design this, it's about ensuring that we design the correct equipment that has the capability and functionality to perform both under new and existing operational procedures throughout anywhere in the world. A core design philosophy for us is stress transparency, weld integrity, and operational flexibility. What is also important is taking our knowledge of over 50 years of welding and applying that training and understanding of the equipment and the methodologies. I often use an example that there is no point in buying a Ferrari if you're not going to use it like a Ferrari. Ultimately, if you're just going down to the shops and not going to put the foot down, you might as well buy a cheaper option. So the equipment and the design. We have our H650 welder head and the puller light. Now what this does is it eliminates the unnecessary force transmission through the actual welder head itself, allowing it to focus on making a quality weld. We also have the independent control of the rail gap, the alignment of the weld, the tension of the weld, but the final release of the weld as well. So what this allows us to do is cut a gap and have the puller light itself actually pull the rail up. And we can also check the load charts to ensure that the weld can be sufficiently made. It also allows us to conduct pre-alignment versus, say, integrated welder heads that have the tensioning system built in. The difference for us is we're able to pull the rail up and actually apply correct rail geometry to it without guessing. This ultimately leads to better weld quality. Then from a post-weld tensioning perspective, the system allows us to release the welder head and confirm that the weld that was made was of superior quality and acceptable to the network's tolerances. It also allows us to begin post-weld alignment verifications straight away. So should there be a problem with the weld, we can act straight away, cut it out, and go again. Confirmation of weld conformance immediately allows us to speed up the process and accelerate both the quality control perspectives, but also any other return to service operations, such as refastening the rail to sleepers and removing equipment out of the wayside, ready for mainline running. From a capacity perspective, the puller light has 380 millimetres of stroke. This is the largest available anywhere in the world. It also provides 145 metric tonnes of tensioning capacity. Now what this allows us to do is support large de-stress modules that often weren't capable with other technology. We also are able to do the rail-in, rail-out method, which is a punch mark method whereby if we go to remove a defect, before we cut the track, we can make punch marks, we can cut the track, remeasure what the movement was made, put in a plug, do one free weld, and then come up to the closure weld. understanding what the gap that we need to restore track to its previous stresses, we can do that calculation, overlap the rail, and use the intelligence of the system so that upon the final tense, we restore track to its original condition. Now, a lot of this is all thanks to the Hollywood IntelliWeld control system. As I said, this system has been run out across over 200 welders, both from our internal fleet as well as to other customers around the world. It utilises intelligent feedback loops to automate control of key parameters, such as burn, voltage, and upset. It's using these controls that allows us to produce a consistent but also minimal weld consumption, which is vital for a rail stress accuracy. Now, this limited consumption is what we call the low consumption weld. It is a standard practice for us across North America and has been incorporated into the ARIMA Manual for Railway Engineering in 2009. Now, low consumption welding was brought about by working with our customers, and it is a strategic advantage for in-track closure welding. It applies a different philosophy in terms of rail stresses. Rather than going back to a stress to a desired NRT, we can take a principle whereby we at least want to ensure that we maintain a tensive state in the rail. When paired with the puller light, it enables full restoration of rail stress, but also eliminates the need to unfasten unnecessary long lengths of rail due to its minimum consumption. This in turn reduces alternating rail stresses outside of the weld zone and surrounding work activities. Our goal and objective is to reduce the amount that we interfere with the existing rail infrastructure. Ultimately, this disruption to rail infrastructure also reduces the total workforce exposure, providing a safer weld for our crews. Now, it's a transparent system that delivers intelligent verification as well. Weld certificates for verification of the welding inputs are produced automatically for every weld. But what we do is we separate the weld graphs from the tensioning system as well. So 2 separate graphs are done. What this allows is our customers to clearly visualise the tensioning that was used during the pre-stressing, state. It also allows weld verification through comparison of theoretical force calculations. So we can calculate what the force should have been required to bring the rail back to its tensive state, and then compare that to what we've actually achieved. And that's working in being transparent with our customers. This separates the data between the tensioning of the puller light and the weld quality. The final result is a technologically superior field-proven solution for rail stress restoration and closure welding. So I now supply a case study. This is a rail stress adjustment that was done on a heavy haul network in the Pilbara region of Western Australia. The equipment used was our Holland Deluxe International container with IntelliWeld 2.0, our H650 welder head, and the puller light. Now, the scope of work for us was a rail adjustment whereby they wanted to complete an 1,800 metre bi-directional de-stress. The rail size was 68 kg rail, so a very large rail. Now, the desired NRT for this particular network was 40 degrees. The actual rail temperature at the particular time was 28 degrees Celsius. So the weld type we used was a low consumption flash butt weld. Now, the adjustment calculation used for this particular network is the adjustment length is equal to the NRT minus the actual times the free rail length times the coefficient used by that particular network being 0.0115. Now, the adjustment required was 289 millimetres, and the adjustment achieved on this day was 293 millimetres. So the NRT that we achieved was 40.19 degrees, or within less than 0.5% of the desired. So in terms of quality, that is very, very accurate. Now, I hope you're all able to sort of see to the right, there's a picture of a production report that's standard for every weld within our system. What that does is, you can see it's a number of automated inputs directly comes from the system, but also the operator. So we can put in for the de-stressing length that we've done, the number of people that were used in the crew, the number of rails that we cut, how many rails were ground. So in this particular case, 2, because when we cut track, what we found is that the original rail was laid at a higher than the NRT, therefore it was rail deficient. The system then automatically logs the weld number. It gives you the start time of the weld, the finish time of the weld, and in this case you can see to perform a LCW 68 kg weld, it only takes 96 seconds. It also gives you the kilometre location of the weld and the GPS location. We're able to record the temperature at which the rail was done and the location of the weld in terms of which rail, whether it be east, west, north or south. It also shows you the weld schedule we use. And when we talk about transparency, that's about the weld qualification. During our qualification process, we determine what makes ultimately the best weld, and then our operators use that, but our clients are able to see that we are definitely using exactly what we say we are. It also allows us to put in the headwear of the rail, so that gives us an analysis of the rail condition at that particular location for our customers. In this particular circumstance, each rail had 1 mil headwear. And then finally, we can put in notes. So you can see here that they've put in notes that it's a closure weld. The tonnage used was 68 tonnes, so that was 40 tonnes for the upset force and 28 tonnes for the actual tensioning force. And so if you were to do the theoretical calculation, it would also come up as a required tension force of 28 tonnes.
May I request to please consider?
Finally, you can see the photos that are capable. That our operators will take a photo of the weld stencil and both sides of the weld. So an engineering team from the rail infrastructure manager can clearly see all the information they need, and this is directly uploaded daily. So there's no need to chase paper copies. All the information is directly there to help understand about the rail network. So I want to leave with this. We are a rail technology company that is a supplier to you. Our objective is to understand what your problems are and design things that you can solve those problems. We look forward to understanding about the Indian Railways and how we can further provide our assistance that sees mutually beneficial outcomes. I encourage any questions. I certainly hope I can answer them, but if not, I will refer to our team in the States. And whether there be questions about flush butt welding or the cricket, I welcome the whole lot. Thank you very much for having me.
Thank you very much. Now, the hand over to third speaker, Mr. Rafael Marotta. Over to Mr. Rafael Marotta. Thank you.
So, good morning to everyone. It's a pleasure to be here in Delhi with fellow railway professionals. This is also my first time in India. It's been a pleasure. I really enjoyed the time here, and I hope to be back soon. So, my name is Rafael. I've been working in the railway industry for the last 15 years, mainly in the field of vehicle track interaction and track dynamics. Today our presentation is about the role of elasticity in the maintenance reduction and track design optimization. So we will start talking quickly about Getzner. It's a quick overview, and also I will highlight some of our railway solutions. We will be talking about the heavy haul environment and its special requirements. Next, we go to the elastic solutions and how they provide some special benefits for the track upper and infrastructure. And we will close the presentation with some real-world case studies that we've obtained in the last 10 years of experience with our products, equipping tracks all over the world. So Getzner is a global expert in superstructure protection and vibration mitigation. This is a picture of our office. It's next to the border with Switzerland and Liechtenstein. We are a system optimizer. We support not only heavy haul, but also mainline and urban rail networks. And we use elastic solution basically to increase infrastructure resilience and minimize track downtimes. That's the ultimate goal of superstructure optimization. We have proven solutions. Our products, they were tested, as I said, all over the world under axle loads varying from 25 to 32.5. I would also say that recently, not recently, but since some years, we have also products in Australia where the axle loads are around 45 tons per axle. So that's our history in the heavy haul systems. And when it comes to heavy haul, we have mainly three products. We have the under slipper pads, we have the under ballast mats, we have the rail pads, and those are the focus. These are the focus of the presentation today. So, as I said, we are not only a component manufacturer, we are a solution provider, and therefore we have a lot of R&D going on at Getzner. We have three areas in the R&D department. We are able to provide, to run simulations. Here I'm talking mainly about finite element analysis, also multi-body simulations. We are able to carry out all of those things in-house, but we also have some external partners when it's needed. We have our own laboratory where we carry out all the tests, the fatigue tests, and everything which is required by the standards. We are able to carry out these tests in-house. And we are also able to instrument the track when it's required by a customer. So we also have experts who can work with pressure sensors, strain gauges, and all sorts of this instrumentation equipment to verify the performance of our products on the track. So that's the Getzner R&D framework. So today we are talking mainly about heavy haul. And the heavy haul lines, they have very special requirements. And why they do have these special requirements? Because this is a very special environment. When we talk about heavy haul, according to the International Heavy Haul Association, we have three criteria. Those are companies which operate regularly trains with axle loads higher than 25 tons per axle, trains with masses greater than 5,000 tons, and annual transportation over 20 MGTs. If you meet two of those three criteria, that means that you are a heavy haul operator. So this special environment with such a high loads, with this high axle load, with longer trains, this ultimately results in higher stress to the track. And as an operator and as an infrastructure manager, what you want from the track is higher availability, less downtimes, and of course, safety. So, as I mentioned previously, those are the products that we offer for heavy haul systems. We have the under slipper pads. This is the first picture from the left to the right. This is the elastic element that goes between the bottom of the slipper and the top of the ballast. We also do have the rail pads between the top of the concrete slipper and the base of the rail. And we also have the under ballast mats, which are applied in some special situations, specifically on the transition zones, for example, between the open track and bridges. So these products, they have some special characteristics. They are reliable, homogeneous, and also they offer permanent elasticity over the time. They can withstand short-term overloading, even if this is really extreme. They are water resistant. They are fire retardant. This might be important in some special situations. And they have fast and easy installation. So we were talking 2 slides before about higher loads, higher axle loads, longer train. In such a harsh system, if the ballast is not well protected or maintained, it becomes the weakest link for the infrastructure manager or for the railway operator. In the next slides, we have some examples of very common defects that you may find on your track, especially in the areas which are subjected to the higher stress. So this is a white spot. This you encounter frequently in the transition areas, I mean, the stiffness transition areas from open track to more stiff structures like bridges and tunnels. This difference in stiffness ultimately results in higher vertical loads. So you may encounter this kind of defects on your track, especially in these areas. You also have the crushed ballast. I mean, from time to time, you have to do some tamping on the track. The track is also subjected to loads over a given period of time. So this is the result to the ballast. The ballast may be found at these conditions if the track is not properly maintained. Another example, again in a transition zone where you have higher loads and higher impacts, may have some hanging slippers. When the slipper is hanging, once the track runs over it, it causes even higher impacts. And this also causes the crushed ballast that we saw in the previous slide. So I'm sure you guys are all familiar with these defects, but what is interesting is what is coming next, is how the elasticity can provide the system with more resilience, and therefore you can avoid this kind of problems. This is another type of the defect. This is a concrete slipper with a crack right on the center. This is also very common, especially when you don't have the right support at the ends of these sleepers. This also occurs if you don't have a superstructure protection, proper maintenance, and in daily basis, it's really hard to manage this kind of situation. So speaking of our products, here I'm talking about the main characteristics that allow for better superstructure protection. In this case, ultimately, all the elastic elements, they aim to provide a greater contact area. With a greater contact area, you reduce the stress, and by reducing the stress, you reduce the track failures, and you increase the availability of the track. So you see at the left part of this sleeper, unpadded sleeper, so you see clearly the contact area between the sleeper and the ballast is very little, and then on the right hand of the sleeper, you see the increased contact area, which is only possible with an elastoplastic element. So that's the principle through which our products work, and that's how we provide a superstructure protection. This is a real-world example on an unpadded sleeper, and the padded sleeper, you can see clearly how the ballast stones, they penetrate at the bottom of the sleeper, and this causes higher stress. And I will show you in the next slide some real-world examples. So how much can ballast contact pressure be reduced with under sleeper pads? So the assumption is that with an unpadded sleeper, usually the average contact area is around 4% of the bottom of the sleeper. So the softer the USP, the under sleeper pad, the bigger the contact patch, the lower the ballast contact pressure. But you have to control the rail deflection. That's a key feature, a key characteristic of our products. This is the elastoplastic behavior. You see that when the undersleeper pad is subjected to higher loads, it experiences some deformation, but after a while, you show this slow recovery. That means that the undersleeper pad is not damaged, even when subjected to that axial loads that I mentioned previously, with that extreme annual tonnage. This does not result in a permanent damage to our products, and that's what sustains the performance over a long period of time. Those are some lab tests that were carried out in-house, but you also find some examples like this in academic papers. Many similar tests were produced by universities. We have a comparison of polyurethane, undersleeper pads, EVA, and elastoplastic polyurethane. So what we show here is that you can increase the contact area by, in this case, around 80%, 76%. And these were the results that we measured with our sensors. This is not theoretical, this is our real-world measurements. Then we start talking about some case studies. The first one was produced by Vale. These are real measurements on the track. On the y-axis, you see the standard deviation measurements over different runs. I think this period, I'm not sure, but I think it's 4 years of measurements at Vale. As you see, Vale transports annually 280 MGTs. So 4 times 280, we're talking roughly about 1,200 MGTs. At the center of this graph, you see a track section equipped with undersleeper pads, and on the left side and on the right side, you see the sections which were not equipped with undersleeper pads. We can say that we reduced the track degradation in this case by nearly 100% when we compare the unpadded sections with the padded sections. Again, this is a track section at Vale, and what you see again is the track degradation over the time and the moment when the track was stamped, where Vale carried out tamping. We see clearly that the section, the blue line, which was equipped with undersleeper pads, performs way better than the other two that were not equipped with undersleeper pads. The degradation rate was reduced, as I said, nearly by 100% in this case. That means basically for the infrastructure manager, less track geometry defects, less time needed for unplanned maintenance, and therefore higher availability. Another real-world example, this one is in China, in Dakin Railway. This operates with 25 tons per axle, and the annual transport is 450 MGTs. We equipped the track again with undersleeper pads in this section. Before they had many problems, especially with crushed ballast, broken fasteners, and they decided to go for this solution, aiming for a higher availability and less downtime, especially in such a busy line. You don't really have time to carry out maintenance as frequent as you may have in tracks where the demand is not that high. So that's why they decided to equip the track with undersleeper pads, and the results are shown in this slide here. It's very interesting to see that the track degradation was actually reduced, that's clear at this graph, but especially at the joints, you see even more clearly the benefits. In this case, the degradation rate was reduced by more than 100%. So this might be very interesting for some operators. We know that joints, usually, they are a huge problem because of the discontinuity associated to the different stiffness in that area. You may end up with higher maintenance. You may need to maintain the joint more frequently when compared to the open track. So we see in this specific example that our products, they deliver special benefits when it comes also to joints. So this is the MRS experience. This is a field instrumentation which was carried out at MRS. Antonio, who was presenting yesterday, he was leading these field studies. So this is also a real-world example. The average contact area without the undersleeper pads, this is a real-world example, as I said, was measured, so it was around 6%, also agreeing with the lab test that we had carried out at Getzner, and also this agrees with the experience of other railway operators. And the tamping cycle reduction at MRS after equipping the track with undersleeper pad was increased by 2 to 3 times. The average pressure reduction from 1.1 to 0.5 megapascals. And then we come to the most important benefit of elasticity. This is the LCC analysis. This is a very important tool when it comes to track maintenance strategy because it takes into account not only the CapEx, but also the OpEx. That means the total cost of ownership of the track. So the cost to build the track plus the costs to maintain the track over a given period of time. So this would be a baseline scenario. And then, depending on your strategy, you may decide to build now and fix later. If you use the LCC analysis, as I mentioned, over a given period of time, this strategy may result in non-optimal LCC, let's put it this way. But when you decide to go for a more preventive maintenance, or when you decide to implement elasticity on your track to optimize the system, although you have investment cost at the beginning because you have to equip the sleeper with the undersleeper pads, over a given period of time because of the reduction of maintenance and also because of the costs associated to track downtime, availability, you may end up, or you will end up with an optimized LCC. You can say that you can optimize the LCC by 30% when you're equipping the track with undersleeper pads. This is...
May I remind you?
Okay. This is also a LCC analysis. What is important to notice in this graph is that especially when you increase the annual transportation or the daily transportation, the more you transport, the more important is the role of elasticity for your track. And then the last example that I brought for today's presentation is the track design optimization. We've been discussing how elasticity can increase the contact area and therefore reduce the stress which the track is subjected to. And in some specific situations, this might be very important, especially when building the tracks. This is a study carried out at Austria. Different ballast stones were analyzed. We had premium ballasts like basalt and granite, and we had other types of stones like dunite, calcite. And settlement tests were carried out at the laboratory with undersleeper pads and without undersleeper pads. What we see is that even non-premium ballast behaves very well when the track is equipped with undersleeper pads because of the stress reductions. You may have the same results that you would obtain by using granite when building your track. This also allows for design optimization. You can even build the track not with 30 centimeters, but you can build the track with 20 centimeters of ballast, for example. This might be important if you don't have a quarry close to the railroad or if you don't have a premium ballast available in your country. This is a conclusion. And one last key characteristics of our products is that they can also improve the track lateral resistance, which might be important, especially when it comes to track buckling prevention. This type of defect is also important because it's really hard to predict. Even if you carry out measurements frequently on your track, it's not that easy to predict when the track buckling will happen. So you can use also elasticity to prevent this kind of incidents. That's a real-world example when we compare wooden sleepers with unpadded concrete sleepers and padded concrete sleepers, and how we can increase the lateral resistance with undersleeper pads. Those are the laboratory tests, which agrees pretty well with the real-world examples. And this is the conclusion of today's presentation. Elastic components can reduce maintenance needs. Field studies in Brazil, China, and also showed that the undersleeper pads and UBMs can reduce track settlement by 65%, extending maintenance intervals by up to 2.75 times or more. It also allows for lower capex through optimized design. This is the last example that I brought for today's presentation. Elastic layers enable the reduction of ballast thickness and the use of non-premium ballast. We have validated performance in heavy haul conditions, benefits confirmed under axial loads ranging from 25 to 32.5, and traffic levels up to 450 MGTs annually. Improved infrastructure resilience, elasticity, increase the uniformity of support, reduces dynamic stress, and minimize long-term degradation of the track superstructure. And last but not least, we have proven track availability gains. Case studies report enhanced track geometry stability and tamping reductions in high degradation zones, even under extreme traffic demands. So, thank you.
Thank you. Now the last paper is by Mr. Anmol Kaul. Mr. Anmol Kaul, over to you. Thank you.
Good morning, everyone. Let me start with thanking DFCCIL. What a wonderful occasion. And I would like to again come back to the main topic that we were invited here for, which was how do we maintain, how do we move towards maintaining towards predictive maintenance. And in that context, I will derive from the wisdom that we had with the discussions that were preceding my session, wherein we said that, to implement AI, ML, and the cutting-edge technologies, we need to identify the realistic problems that railways faces, and to really try to attempt to solve those problems by using the cutting-edge technologies. And today's presentation is a step towards that. What I'm going to talk about is, yesterday we saw how the placer machines are heavily used in automated and semi-automated fashions for track maintenance. And today we will talk about how such a fleet of machines can be intelligently used to do predictive maintenance. So in that context, the first thing that I think we need to identify is that such futuristic technologies have to have a foundation of what we want to create out of the value that we derive from the data. And as we also discussed yesterday, we want to move towards efficiency, we want to move towards productivity, and we want to move towards availability. This would be where we encash the technology that has been implemented from predictive point of view. And that is, I think, where my presentation would try to focus on. So what we want to start with is that how do we capture the end-to-end process? And these are the, let's say, the blocks which signify that what needs to be done for you to take a step towards a predictive maintenance. So we do the pre-measurements. We basically have a technology called Datamatic, which ensures that the data that is captured by the pre-measurements are analyzed and work preparation is done all seamlessly, and an execution plan is provided to the tamping machine. When the execution happens, then there is a feedback loop that the Datamatics enables to synchronize what happened after the tamping was done, what happened after the maintenance was done. This end-to-end loop ensures that you have the desired correct data to go to the next step of predictive maintenance. Not only that, it ensures that there is a transparency of what was planned and how it was executed. So as planned to as executed. Now, once we deep dive into this, we come to the two critical elements of this technology. One is what is called as machine data connect, and one is what is called as machine condition observer. Machine data connect is basically a IIoT device which is present in the machines, and the machine condition observer is a web portal based analysis portal where you would get the insights of what has happened and how the next steps have to be properly planned. So as I said, you have a device onto the machines wherein it records not only what was done and how it was done, but also in real time you can see the data what an operator typically would see when he's operating the machine. So that is how you basically come to the first step of realizing the data in a live sense. And how do we do that is basically, now you basically can think about a problem wherein you have different fleets of such kind of machines. So all of these machines now start talking to the centralized, let's say, a repository where all this data is collected, and then you have the next level of automation that kicks in. So what happens next is that all of these data come to a portal wherein you're storing the data, analyzing the data, and then converting it into an actionable intelligence. Now, as I was saying, these steps are, it's very critical that they have to be implemented in a practical sense, and the figures on the screen show you that how Plaza has been doing that across the globe. You can see more than 1,300 and more machines that are connected, 2,000 and more dashboards that are there, which can provide you the actionable intelligence. And now that you have the data, now we move to the next step, which is how do I use this to come to the stage of predictive maintenance? And that's where you have the machine condition observer, where you have the list of all the machines that are there in your fleet. You can in real time see the position and tracking of the machines. You would be able to build a personalized way of looking at the data. But this is just the first step. What you now have is that you would be able to do a geofencing, which means that the machine will tell you that you have the machine is in this zone without you even basically monitoring that. So you are now moving towards, let's say, machine talking to you. Now you also have, in these kind of cutting edge technologies, which is IIoT technologies, the most important element is basically the safety associated with it. So you would be able to spot all incidences which would trigger such kind of alarms, which are now captured live for you. You would be able to call in a remote assistance in case there is any issues there. And you would be also able to see what an operator sees, as I was saying. And we also saw that emissions are also a very big topic nowadays. So you would be able to track how the machine has been performing. You would be able to also track what is the emission, how much emission has happened, and how do you basically best plan that. But also the machine will record how and when it was maintained, so that you move towards the predictive part of it. You have machines will start talking to you about when they have exceeded something which was by design not to be exceeded. So you have notifications coming in. Now we are moving into a zone where you are not actually actively maintaining the machine. The machine itself is talking to you and telling you that maybe these parameters or maybe these systems need to have, need to be looked into or need some maintenance. You would basically be able to better plan, if there are frequent travels with less work involved, you would be able to better plan that, and this kind of analytics would be available to you. That brings us to what should I now analyze? Now that I have a fleet, I know how the fleet is doing, I know how each machine is doing. I can walk back in time to compare how I was doing last year for the specific season, for the specific track, for the specific region or location, and how am I doing now, how these machines were performing in that segment, and now how are they performing now, so that it gives me a base for doing predictive analytics, so that it gives me a base for giving me actionable intelligence. And that's where it opens doors to advanced data analytics. Now, as I said, it's important not only to have all this data, but also that this data gives you actionable items. And there, what you see on the screen is that now the machine will start telling you that, considering that this is the record of how it has been operating, these are the things where probably the machine is giving you more alarms. Probably this is where there is this is how your engine or your traction has been performing, this is how the machine has been performing, and probably if this is the reason that you are seeing this alarm, so probably this is the reason, and probably this is where you need to intervene before this situation can happen. So that's where we systematically move from doing a preventive maintenance to a predictive maintenance. And as a part of actionable intelligence, you also need to have it in proper formats. And what you see on the screen is basically health checks that the machine would now run automatically and tell you that if there is any problems associated, and how do you basically predict or rectify that. This is an example of what we have done with the Indian Railways, wherein you basically are able to see not only the summary of or aggregation of the data of the machines or the fleet that has been operating, but also specific inputs where I would probably like more intelligence, so that those specific customizations are also now possible with this data. And ultimately, we want to monitor what was the quality of the work that was done. So the machine now monitors itself with respect to how was the work done, and then specifically tells you if there are any spots which have been missed from a quality point of view. With real-time locations, you would be able to provide within a particular time span what the machine has been doing and how it has been performing. And as we were discussing, these health checks can become very, very elaborate with respect to analysis, wherein you can also do statistical analysis based on how these health checks have propped up onto the machine, and how do you derive insights, which are mathematical insights out of that. So I would like to also stress upon the fact that whatever analytics and other features that we saw, it is a joint effort with the focus on Make in India. We have a team here which helps us to realize all these things that we saw in collaboration between Plaza India, Plaza and Theatre, and the TMC. So a really good example of how you ensure the customer satisfaction by correlating whatever is the best available across the globe and bring it to India. I'm sure you would be having more questions. Feel free to please reach out to me, and I would definitely like to get back to you with the answers. But thanks a lot.
Thank you, Mr. Anmol. These papers are very useful for the maintenance and increasing the life cycle cost for the heavy haul system. which has created a lot of interest in the seminar, in the meeting. And so we have received so many questions. 7 queries is from Mr. Penrol. 5 queries is for Mr. Benjamin. 1 is for Mr. Rafael, and another one is for Mr. Anmol. So to cut short time, what I will do, I will read all the questions because these questions are interrelated with each other, and a summarized one reply can be given. And if anything further is required, that can be discussed during the tea break. So let me read these 7 questions for Mr. Juan. So this is, first is, under sleeper pads are good innovative solutions. At Monash IRT, we have developed circular economical next generation composite plastic sleepers working with Penrol. Have you done any research with the USP to use recycled rubber? This is from Professor Ravirendran. Instead of replying each question, let me read all the 7, then you can give a comprehensive reply.
Okay, sir.
The second question is, this is just to cut short time. The second question is from Mr. Arun Kumar Tiwari. The question is, by using USP, what will be the impact on rail bending stress, and what will be impact in bending strength with the rail? The third question is it necessary to replace UBM if it is damaged during tamping of track? If yes, then how minimum length of UBM will be required to replace? This is from Hridesh Kumar, Noida DFCCIL. The next question is, the use of under sleeper rubber pads, even under ballast rubber pads, bound to significantly change rail wheel interactions, maybe for the worst, though UTS rails, high UTS rails. This is from Shri Deepak Krishnaji. We have different types of USP made up of PUR and RR. What will be the applications of this type of material, which will be more suitable for transition zones and heavy haul? From Dr. Dinesh. Again, as I understand, stiffness of rail pads would be different for or under ballast pads. Ballasted track and slab tracks, it is also different for heavy haul and high speed. As we are operating a mixed traffic on some network, how to optimize the stiffness of the rubber pad components? From Tushar Pandey. This is tamping resilience. How have Penrol seen the USP last against regular tamping cycles? Is there a limit to how many times they can be tamped? From Mr. Bean Haynes. And in ERS, which material prefabricated structure is made up of? How much more expensive is ERS as compared to conventional system? From Amit Kumar Concord. And another question here is, in USP and UBM, only the electricity responsible for increasing contact area, only the resistance and elasticity. Okay, I correct myself. In USP and UBM, only the resilience and elasticity is responsible for increasing contact area. So these are 7, 8 questions. One more question. You have one. Yeah.
Oh, sorry, thank you. My question also to add this, you have, what's the total service life you have experienced in your unslipper pads until now? The second one was the same context, is about what's material you use to produce those unslipper pads. Thank you.
Now there is one more question on the same topic of UBM under ballast pads. Once laid in track, it is very difficult to inspect under sleeper pads and under ballast mats. How do we check its integrity during service? Also, please comment on its life. This is from Director Pankaj Saxena. It pertains to both Mr. Rafael and Mr. Joan. So, you can give a comprehensive reply. The details can be discussed over the cup of tea. Yeah.
Totally. So I think many are related with material lifetime. So let's maybe make a general point here. At the end, when specialist companies like big industrial groups like Penrol or Getzner, we investigate materials. We are trying to find systems. I think it's important to deviate the conversation to what is relevant. Materials per se are meaningless. It's the strength and industrial strength of companies and manufacturers and the quality capacity and engineering who makes specific systems based on materials. Today, what we use in Pandrol is everything related with recycled rubber and resin-bonded rubber. We are investigating many. And it's important, I think, this message, because when we look at what the standard should be, there is an international standard who will never forbid or approve any material per se. It has to pass test, laboratory conditions, real track. This is the focus of companies like us. And actually, that's the guarantee for asset managers that you are not receiving a material, but a developed engineered system proven. At the same time, in today's market, we are always in constant R&D. And if there is a trend, and this is a personal opinion, I think the trend is going with proven solutions such as polyurethane, because it has excellent base qualities, and rubber simply out of the 30 years experience, but it's always backed up by a certain industrial capacity. Again, we propose always to, for the technology adoption, to enter through existing EN standard, in this case for the slipper patch, because it's going to define laboratory conditions which are relevant for the life and performance. This should be this objective data. Also, the practical things, I have a couple of practical questions very interesting. When it comes to maintenance operations, number one, the tamping should not affect. And at the end, in practical terms, when you see the metal of the tamping machines, there are two things. These systems they need to be super well bonded. This is actually also a minimum requisite normally in pull-out, but we are talking about 7, 10, 20 millimeters. So there is not going to be a necessary interaction. That's the idea. There is also an offset. So we don't see, the best thing is the practical life. We don't see operators, in our case, we know better the European references, more than 25 years. We don't see any problem with this interaction. Also with tamping, there is no limit. I mean, the whole point is to reduce tamping, especially in critical sections. So that should not be a problem. Also linked with UVM, conceptually, what you need to do is to create the bed, the elastic bed for the coupling of the underballast mat should be bigger than the ballast bed, which was another question. For that, you also have a geotextile protection. So the idea, technically, what we see, and this is an installation point, people are very smart outside. They simply get a wider bed of underballast mats to make sure that you always have this excess. Because the whole point of functioning is that you are covering the whole structure. So instead of 4, let's say you put 4.3. So you always have this excess. The second point, I was trying to, 9 questions, I was trying to make some common points.
Because there are 8, 9 questions, so you can give
a stiffness questions, which I think is very,
gist. The details can be discussed to cut short time, right?
Exactly. So again, 3 points. Rely on expertise and 30 years technology. Always start with lab testing conditions. It's the only way today to simulate the behavior is going to be tests like vibrogear, fatigue testing, and the loadings are different. There is also another question. Every category needs a different approach. There is no one single solution, even when it comes to stiffness, or it doesn't exist. Let the science and the data speak, and it's better to approach each case. Stiffness for transitions has to be fine-tuned, and it's case-related. So it's about having these options. Thank you.
Thank you, Mr. Juan. Now, there are 4 questions from Mr. Benjamin. I will read all these 4 questions, and you can give a gist and a summary of the reply. Details can be discussed over the cup of tea. Certainly. Please let us know about the time required for rail in, rail out, and in actual welding process. Has it also been used on ballastless track? This is from Mr. Atul Kharid from DMRC. The second is, what is the requirement of time for one welding, and can it be reduced further? It is seen in existing machines that approximately 8 minutes are taken by software to confirm whether it is good or bad weld. This is from Anurag Yadav, DFCCIL. The third question is, can rail stress adjustment by flash butt welding equipment be done if rail temperature is way above NRT desired? This is from Mr. Vipul Kumar. And the last question is, whether any standalone equipment worldwide exists for measuring the SFT stress-free temperature when rail is actually in comparison. This is from Mr. Arun Kumar.
Firstly, thank you very much, everyone, for the questions. I'll do my best to answer, but please do come up and see me during the break if you feel I haven't quite addressed it correctly. In terms of ballast-less track, we have actually just recently completed a project in Australia in a tunnel environment. So the answer is yes, we have done it and quite successfully. It does have its unique challenges, of which we sort of had to draw on our experience and use our equipment in a very bespoke way. I'd be happy to sort of further explain how we went about that and adjust it accordingly. In terms of the time for the world, I believe the sort of the question around that, understanding traditional systems with the 8-minute hold time. So what Holland have done is they've actually taken a metallurgical approach. So we have our own weld laboratory that we do quite significant testing with our own metallurgists and engineers. So we look at it from a science perspective. So ultimately we will hold the rail under a tent with the puller light while the weld solidifies, and we've done research and development that shows that at 372 degrees Celsius the weld is now solidified enough to have structural integrity to be able to withstand those tensive forces. So we don't hold the rail for a set amount of time. We look at it at a metallurgical approach and check the temperature. Now that will vary depending on a number of aspects, including ambient temperature. The other side of it is that as soon as the welder head has upset and actually sheared through, it itself will begin the release while the puller holds it. Now once it's finished the shearing process, we will get confirmation from the system then, has it met all the correct parameters so that the weld itself has passed. So whereas other welders, systems will not tell you whether or not the weld has passed until 8 minutes or 480 seconds has passed, our system tells you straight away. And it's at that point that there's an operational advantage, because you can now begin to conduct all those other activities surrounding the welding, including refastening the system. So essentially, we're 8 minutes ahead of any other welder. I hope that answers that question. In terms of NRT and adjusting the stress when the rail temperature is above the desired NRT, this is one of the greatest challenges that rail networks face. And I take sort of our experience in environments such as the Pilbara region of Western Australia, and I'm sure it's very similar to here in India. There are very large periods of time, and certainly during summer, where you will hit the NRT and above at a very early stage, and unfortunately it's uncontrollable, and so ultimately no, we cannot readjust the rail back to an NRT once the rail temperature is above the desired NRT. There is a couple of ways which networks have tried, and depending on the length of the module you're trying to adjust, you can look to wet the rail to dramatically cool it down. However, a very hard process to control. And what you ultimately find along the rail segment, you now change. There's such a discrepancy rather than it being equalised. It now changes what we call cold spots and hot spots in the rail. So I'd love to one day tell you that we have the technology to apply a compressive force, but we're not quite there yet. So I'll thank you very much for that one, and I apologise. I thought I'd written down the fourth question, but the time in terms of rail in and rail out as well, I believe, was one of the questions. So the process itself is relatively quick. So if I sort of think about it from a rail replacement, what we would do is with large rail campaigns, we would expect to sort of do 2 welds every 10 minutes. That's the speed of the process. If we were to look at it from a rail construction in terms of creating LWRs, our teams would average about 5 minutes between welds. So it really is dependent on the environment and the way it's utilised, but a very, very quick process. And part of that is the finite control of the IntelliWeld getting large rail sections down from the time the operator starts to the time that the weld finishes and shears, 96 seconds. That's sort of really up there with some of the quickest parameters in the world. So I hope I've sufficiently answered, but please, if I'm afraid if I have skipped past or I've forgotten or I haven't quite answered it correctly, please come and see me during the break.
Thank you very much. Now, we are left with only 2 questions from Mr. Anmol. This is regarding pre-measurement and post-measurements. Do you measure revenue vehicle train performance before and after tamping to see whether the tamping has been effective or not? Are these measurements independently done, or is it done by Placer? And the second question is, this is by Professor Ravi Tharan. And the second question is, are you carrying out predictive maintenance of your machines working in India? This is from Shri Mr. S.K. Suri.
The tamping measurements, yes, there is a pre-tamping run, which is called as a pre-measurement run, which basically is done by the Placer machine, tamping machine, which basically helps you to calibrate the tamping that you want to do. But also, not only that, you can also integrate the data from if you have track geometry data from your previous records or from TRCs, that also can be integrated with the solution, in fact. The second question is with respect to are you carrying out predictive maintenance? Yes, predictive maintenance, as I said, is a process, and yes, the machines that are, it also depends upon how much the machines are equipped with. In India, also, there is elementary amount of predictive maintenance that is being performed. As I was talking in my slide, there is a team of engineers who does this as a part of Make in India. We have a big team which does this analytics, not only for Indian fleet, but also for the fleet, global fleets. I hope that that addresses these questions. Thank you.
Thank you. With this, we conclude our first morning session. Thank you to all the 4 speakers. Thank you.
Thank you very much. This session has reinforced that durability isn't just built in materials, it's engineered through intelligent design, precision, and smart data. Thank you for that wonderful exchange of ideas that we had in this session. We will now present tokens of appreciation to our speakers. Ladies and gentlemen, some of our esteemed speakers, as we know, have already been honored yesterday during various sessions that took place. So we take a moment to present mementos to our remaining speakers. May I please request MD DFCCIL, Shri Praveen Kumarji, to kindly please present these tokens, beginning with Mr. Juan Lezcano. Thank you very much for sharing your perspectives with all of us today and for that wonderful presentation. So here's the Statue of Unity, a very special memento to our esteemed speakers and the seminar memento. Once again, a big round of applause, ladies and gentlemen, as we thank each of our speakers for sharing their thoughts, ideas with all of us. Thank you, Mr. Benjamin, for being here with us. We do understand that there may be a few more questions from the audience, but they could be taken up during the imminent tea break, which we will be announcing shortly. Mr. Anmol Kaul, thank you very much for your presentation. We thank all the speakers for their wonderful sharings. Once again, a big round of applause. And Shri Vijay Sharma, who conducted the session, who moderated the session. सभी के लिए जोरदार तालियां. After a stimulating start to the day, it is time to rejuvenate with a refreshing tea. We invite you for refreshments while engaging in fruitful conversations with your fellow attendees. We will reconvene in 15 minutes, please. Sharply 15 minutes. Thank you very much. Please join us in the Leaders' Lounge.
चावल के पास ले गया उसने बैटरी निक्सन दिखा देगा ना, बैटरी निक्सन दिखा देगा ना, देखिए मेरा बैटरी चार्ज हो रहा है, लग नहीं रहा है, फुल चार्ज हो रहा है, बैटरी सोल्यूशन उसमें क्या नाम है, वहाँ पे तो कुछ चेंज तो हुआ नहीं है, बाकी अरे मेरे भाई वर्क की ग्रेड चल रहा है, वो तो मैंने कर दिया, वो तो कट टू कट और प्लस क्या नाम है पूरा वाइट शॉट, जैसे 8-5-6 बंदे एक साथ खड़े होते हैं, उनको 2-2 1 मिनट का बना दिया, बाकी वो सारे दिखा दिए साइड से लेंस थोड़ा यहाँ पे भी मार देना, मच्छर बहुत काट रहे हैं हमारे, काले कपड़ा मच्छर ज़्यादा आते हैं, अब गेट पे भी हमारा ध्यान रखा करो।
बुलाओ इन लड़कों को, कहाँ चले जाते हैं यार, यही समझ में आता है, कहाँ गए? ऐसा कौन सा इनको बिजनेस चल रहा है कि हम छोड़ कर जाते हैं? एक ही बैठा है बस, एक बैठा है, बाकी कहाँ है? दो। बुलाओ उनको यार।
दिवाकर जी, प्रेजेंटेशन लगा दीजिए।
हर घंटे में, हर मिनट में हो गया शुरू, तो खत्म भी करना।
May I please request all our delegates to kindly please return to their seats. We are about to begin shortly. May I please request everyone to be seated. All our attendees of the Global Heavy Haul Seminar, those who have had their refreshments are requested to kindly please step inside the summit hall and be seated as soon as possible. Thank you. Requesting all the attendees of the seminar to kindly please step back inside the summit hall and be seated as soon as possible. We are about to begin. Ladies and gentlemen, may I please request everyone to be seated as soon as possible. We are about to begin. सभी से निवेदन है कि जहाँ तक भी आवाज़ पहुँच रही है आप सभी लौट आएं, क्योंकि समय की सीमा भी है. हमें निर्धारित समय पर इस सेमिनार को ख़त्म करना है, कंक्लूड करना है. उसके लिए निवेदन है कि आप प्लीज़ सब लोग वापस अपनी जगह पर आकर बैठ जाएं. May I please invite and request everyone to please be seated as soon as possible. Ladies and gentlemen, there are special coffee table books signed by the MD, Dedicated Freight Corridor, Shri Praveen Kumarji, which have been placed on the tables of all our esteemed speakers. This is about the journey of DFC. Though some speakers have already been presented with these books in the office already, for the others we have placed them at the tables. So these coffee table books about the journey of DFC have been placed on the tables of all our esteemed speakers. And we can also see a digital copy right here on the screen, which is visible to all of us. So this is a very special gesture from Shri Praveen Kumarji, signed by him and presented to all our esteemed speakers. Thank you very much. Welcome back after the refreshing and rejuvenating tea break that all of us really enjoyed. Ladies and gentlemen, we are diving into the final technical session on the topic of heavy haul rail infrastructure, performance, reliability, and sustainability. This is going to be the final technical session of this remarkable seminar. This session features practical experiences from two of India's most progressive infrastructure organizations. To guide this important discussion, may I please request the moderator, Shri Mahesh Gupta ji, a respected expert in rail infrastructure and life cycle management, to kindly lead the session, introduce the speakers, and begin with the deliberations. Very quickly, over to you, sir.
Thank you, ma'am. Sabhi ko namaskar. Good afternoon, all. We have now come to the final technical session of this landmark seminar. This session shifts the focus from the global solution to homegrown strategic drawing from real-world implementation on India's most advanced freight railways and metro networks. It's well known that India is now poised to lead the way in heavy haul modernization, and the insights shared in this session will highlight how our institutions are not only adopting international best practices, but also innovating within their own unique operational contexts. There will be 3 papers in this session and will be presented by engineering gems of Indian Railways in their respective fields. The first paper will be presented by Shri Pankaj Saxena, Director Project Planning DFCCIL, a veteran railway technocrat with over 36 years of experience in various facets of railway engineering. Mr. Saxena has been instrumental in shaping DFCCIL's infrastructure planning and maintenance strategy. His presentation will reflect DFCCIL's evolving vision for long-term freight railway infrastructure management, highlighting adoption of most modern approach to support reliability, safety, and life cycle performance across large-scale freight networks. Second paper will be from Shri Atul B. Khare, Executive Director, Coordination Project Works, Delhi Metro Rail Corporation, who also has a long experience of railway engineering, including metro rail. Mr. Khare represents the Delhi Metro Rail Corporation, one of India's leading urban transport system. In his presentation, he will share insights how DMRC has adopted rail grinding as a part of its overall rail maintenance planning to ensure reliability, safety, and longevity of rails. The third paper will be presented by Shri R.K. Goyal, Principal Executive Director, Bridges Railway Board, Shri S.K. Sapra, Principal Executive Director, Infra RDSO, Shri P.K. Srivastav, Executive Director, Bridges RDSO, and Shri Manish Kumar, Director, Bridges RDSO. Shri Goyal is considered to be an authority on steel bridges on Indian railways, and perhaps all railwaymen know about him. Shri Sapra and his RDSO associates are also having long experience of various aspects of bridge design, maintenance, and associated problems. Their paper, through a case study, will enlighten us how some critical elements of steel girder bridge can fail due to fatigue, though the static stresses are within the permissible limits. I hope all 3 papers will enlighten all the young engineers present here. I'll request all the authors to kindly maintain the time schedule of around 12 to 15 minutes so that we can have some time to satisfy the queries of the audience also. Over to Mr. Pankaj Saxena for the first paper. Thank you.
Good morning to all. Through this discussion, we'll try to highlight the DFCCIL's transformative role in Indian freight operation, emphasizing attaining sustainability through reliability and efficiency. Our basic emphasis is that sustainability doesn't only limit itself to the environmental footprints, but we should be robust, we should be efficient, and we should be perfectly safe to give a reliable system which derives its longevity, the sustainability through all these parameters. Now here we are basically trying to innovate each and every aspect of the reliability and efficiency of our operation. So I have just highlighted, or rather listed, 3 most important points. We are concentrating on the seamless logistics. As of now, we have about 2,700 kilometers of track with us, route length, and which is all continuous. So right from the eastern part, which is Sonnagar in Bihar, to the western part, very near to the JNPT port, we are connected in one go. And a leg of ours also connects Ludhiana, which is the industrial, food grain, and other items hub in the state of Punjab, and it also covers Haryana. We are also trying to reduce the rationalized costs of operation, and we are trying to bring down the logistics cost also through our efforts, because we are getting extended runs. Our overall system has become built-in efficient, and therefore we are trying to reduce the cost of operation to a great extent. And last but not the least, we are trying to minimize the footprints which we are going to leave after construction of this project and during maintenance of this project also. So therefore, we are basically concentrating on the synergy between reliability, efficiency, and attaining sustainability through it. I'll briefly skip this item, briefly cover this item. We are already aware that our Indian railway lines, which are only 16% of the track length on Golden Quadrilateral, covering a lot of traffic, because of aspirations of people, a lot of passenger trains also keep adding over the years, and therefore, for the freight operation, we are left with less and less paths which have a lot of speed differentials as well. Obviously, the passenger trains always get priority and the freight gets sidelined. And if I am not wrong, over a period of time, the freight speed on Indian Railways has not gone up, but it is either consistent or has gone down. And all these factors ultimately impact the economic activity. As we all know that we are already fourth largest economy in the world, and we are likely to take over as third position, and our growth rate is about 6 to 7% every year. So for any country, and for any country to sustain the growth at that level, the transport sector or the logistics sector has to show a growth rate of about 8 to 10%, then only we can sustain this kind of growth for the country. This is I just want to highlight one point in this. The blue line indicates the railway share in the total transports since independence, and the green line shows the road traffic. This is just the time when we have started operation of DFCCIL. Just by simple mathematical extrapolation, if we think that had this intervention not come at this moment, the graph would have looked much different. So now we'll wait for next 5 to 7 years and see whether this graph overall takes a different shape or not. This is about DFCCIL. The DFCCIL was conceived in 2006, and all the contracts were mostly awarded between 2014 to 2017 and 18, and we have started operation since 2020, late or early 2021. In fact, I was talking to my colleague, Mr. Ravi from Monash University, that when I was 4 years old, then heavy haul operation was started in Australia. And now, when the DFC is 4-year-old, we are breaking all sort of records, all sort of national and international records in freight operation in the country. You will be surprised to know that already our GTKM per year, the gross ton per year carried on DFCCIL track is highest amongst all the zonal railways of the country. Second position is a distant second, that is East Coast Railway. This is a special purpose vehicle, and we have full mandate from planning to operation, to conceive, to finance, to maintain the dedicated freight corridor. I think if I am not wrong, in India, we are second biggest organization, I should say, who is operating the freight trains. Konkan Railway does it, but Konkan Railway does it to a very, very limited scale in a length of almost like 1,000 kilometers, and that too on a single line section. We are bound to achieve, and we'll definitely achieve, that the rail freight share increases over the years, and we will also do a lot to remain sustainable in the transport arrangement which we are making. Our mission is we have to build efficient, safe, economic, and state-of-the-art corridors. We are developing, and we are also developing a lot of Gati Shakti cargo terminals, multimodal logistic parks, and we are trying to achieve our overall objective of eco-friendly freight transport. This is a brief status of our project. The first two corridors which have already been sanctioned and which on which the work is progressing, we have already commissioned about 96%. Eastern dedicated freight corridor has been commissioned fully, which is about 1350 kilometers, and the remaining 1500 kilometers, out of 1500 kilometers, 1400 kilometers we have already commissioned on Western corridor. And I will briefly dwell upon the future plans and our overall plan for the first phase of construction of DFCC lines is about 8,700 kilometers. You can see the magnitude of or rather the scale of the construction, because yesterday in one of the paper I was noting that someone talked about how many steel bridges are there on the dedicated freight corridor network, and the reply was 3. And I don't know, I don't have the exact count, but in our project, only rail flyovers, that is rail over rail, are 53, out of which we are already operating 50 rail flyovers and 3 are under construction in the last phase. This is about, this is about real-time monitoring. Entire network is being managed, is being monitored, is being controlled from only two operation control center. One is located in Prayagraj, which is in Uttar Pradesh for Eastern Corridor, and one is located in Ahmedabad, which is on the Western Corridor. Normally the concept is that we have a control office on Indian Railways after every 300-400 kilometers in the divisional headquarters, and at times away from the divisional headquarters also in the same division. But here we are having only 2 centers, and which are fully equipped, most modern and state of the art. I would in fact request all the delegates here that if they can find time for about 2-3 hours whenever they are in these places, or they can have a dedicated program for that, we can program for these stations, these cities. We can always have a tour for you, and you will be happy to see all these facilities which have been created by us. I will briefly say about the robustness of the system which we have built up. Our track is already fit for 25-ton axle load, which is the highest carrying capacity per wagon on Indian Railways of now. But we have built our bridges and formation to the standard of 32.5-ton axle load. So the entire system is upgradable, and the life which we have taken for the design of our structures is about 100 years. We have already laid our loop lines for 1500 meter length, so we can very easily put our long haul trains also in the loops without any issue, without any major problem. I think I have tried to locate at many places the height of the OHE which is existing amongst different countries. And somehow, based on my information, this is the highest catenary wire height, which is 7.54 meter on our Western corridor, which can easily accommodate 2 containers, one over the other. So, I mean, as per my readings of different world railways, I found that 7.1 meter was the highest, but here we are maintaining 7.5 meter and running double stack container. In fact, I feel that I have forgotten to include one more word, which I was saying in the pictures of my presentation. Somewhere we have to put aesthetics also, because the kind of beautiful containers, one over the other, red, green, blue and all, when they pass, it really gives a kick to each and every DFCCIL person who is working with us. And I'm sure the same feeling must be there in the mind of all the people who see our double stack container trains running over our Western corridor. We are already achieving higher average speeds. Now, unlike other world railways of heavy haul, where I feel that the entry and exit points are very, very limited, maybe 1 or 2. At many places, there is only one loading point from pit, and the other unloading point, which is at the port. But in our case, in this 2700 kilometer, there are, if I am not wrong, more than 40 interconnections. There are more than 40 goods sheds we are connecting. And as a result, our train length, our train run on our DFC corridor is not consistently from one end to the other. And because of this interchange with the railways, we are likely to get little lower speeds because we have to slow down when we have to take over the train from railways, and we also slow down when we have to hand over the trains to railways. Similarly, a lot of bridges, as I was mentioning, we have throughout automatic signaling, which is able to give us headway of 2-kilometer trains. Our electricity line, our OHE lines have been designed such a way that we can run 2 long-haul trains after a gap of 12 minutes. That makes up the overall capacity of the system as 240 trains on each corridor, single haul. So in double haul, we can always have better this thing. Our entire traction is 2 into 25. This is in brief. We have devised the very, very futuristic schedule or dimension for us so that at a later date, in next 30 years, 40 years, 50 years, whenever we have to switch over to some other wider stock or the higher stock, we don't have to do any structural changes in the DFC corridor, and we can easily run these trains. This is little smaller, but you can make out our height of OHE, the width, the train length, the load, and entire traction system is totally different than what it is existing on Indian Railways. These are our inline equipments which are helping us in making our operation relatively safe. We have hot axle box detectors, OMRS, MVIS is totally indigenously developed product which we have already installed, and we are in the process of duplicating or multiplying it on our fleet. And not only on our fleet, it is also planned to be put on Indian Railways tracks also by us. I think I have already covered all these things. We are using all energy efficient items so that we are not dependent. And one more major difference which I feel, our entire network is electrified. We are 100% electrified, even all our sidings, loop lines, and wherever we have connected with Indian Railways, they are all electrified. So our diesel oil consumption or the HSD oil consumption is very, very limited or almost like nil. This is about real-time monitoring, which I said that we have integrated system, we have advanced signaling, we are detecting the trains through our different items, and we are controlling entire operation through DFIS, and you'll be happy to know the DFIS, Dedicated Freight Information System, is our own indigenous product. We have already changed the landscape of transportation in the country. We used to hear a lot of power shortages in the country a few years back, but now we are catering to about 18 to 20 power plants through our eastern corridor and western corridor also partly. And all the plants are having sufficient amount of coal, and our transit time has also reduced by about 30-35%. Similar is the case in the container transport time of western corridor, which is mainly EXIM traffic, and there also we are cutting down the time by at least 1/3. And this train, you might have seen, this is our signature scheme, that we bring lot of trucks through train to different places, and this is a direct impact of safety of the direct impact on the saving of the fuel and saving the congestion on the road as well. I think I will not dwell upon much because we have to limit our time. Now these are our environmental and social management framework items. We have a comprehensive policy for this, and these items we are assessing the impact of all these, just a minute. We have very extensive ESIA, that is Social Impact Assessment Policy. We have recently approved, our management has approved this comprehensive corporate environmental and social framework network. This is to take care of the entire operation, entire construction, and at every stage, what are the items which you have to take care during the construction as well as maintenance of the sections. These are some of the items which we have already done. We have put a lot of noise barriers and waste management policies we have adopted. We have used a lot of concrete infrastructure which was used for temporary works. We have planted a lot of trees. We have done mangrove plantation, and we have a dedicated social and environment management unit, SEMU, which is functioning for last more than 15 years. And we are very, very careful, very, very connected with the problems of land acquisition, the rehabilitations, and the grievance redressal. We have always kept an approach that we have to develop good connect with the people so that their problems are minimized, addressed, and that is the result where we have affected almost like 200,000 people, and we have built our sections, our tracks, by satisfying their requirement and by having elaborate policy on this matter. We have done a lot of community upliftment programs also. We are into this education and skill development, and the key initiatives in this scheme are, these are very recent ones. In 2024-25, as part of our corporate social responsibility, we have undertaken a lot of health and nutrition programs for TB patient in one of the village of Uttar Pradesh near Raebareli. We have also, there is a national scheme of Prime Minister internship program. We are part of it, and we have already sponsored a lot of candidates for skill development out of it. And these are the allotted funds which we have allotted for the present year. And we have also been, although it is not listed here, but we have also been installing few state-of-the-art medical equipments in one of our hospitals in Mumbai, which will benefit by a lot of people across railway organization as well as other organizations. These are our initiatives to reduce the carbon footprints, and as you can see, through electrification and through all other policies which we have adopted, we are likely to save about 457 million ton of carbon dioxide in next 30 years of our operation. We are also planning to enter into this carbon credit market, and I think we have already addressed the issue of congestion to a greater extent. This is all about it. This is all about DFC. In fact, I would add in the last that purposely I have not kept a lot of photographs in this presentation. I want you all to visit these things physically, personally, to appreciate it better. And through this forum, I would request all the delegates present here to make a plan for inspection or for a visit to our DFCCIL facilities. And I'm sure it's much better than what it looks here. Thank you.
Thank you, Mr. Saxena, for giving a good insight to inside of DFCCIL to all the audience. And thanks also from audience side for the standing invitation extended by you to visit the OCCs and DFCCIL. Now I'll request Mr. Atul to go for the next paper. Mr. Khalid.
Thank you, sir. Good morning. Senior Railway Board officers, DFCCIL board members, leaders from the industries, and my dear esteemed friends. I thank you for giving me the opportunity for presenting on experience gained by DMRC on rail grinding with a focus on vibration control. Like any urban metro systems, we also have a challenge of optimizing rail performance and its longevity. Many authorities have adopted standard gauge worldwide, but DMRC, due to legacy, is operating on broad gauge as well as standard gauge. So the issue being faced as of now is the accelerated rail degradation, generation of surface defects, which is induced by, of course, continuous rail-wheel interaction, and at times unfavorable rail-wheel interaction, which is generating surface defects, may lead to groundward vibration, especially at the locations where we have not carried out any vibration mitigation measures due to legacy. To control this, DMRC is using two rail grinders of make of LORAM, that is, one is LRG 18, another is LRG 30. This is in brief just a snapshot about DMRC network. Currently we are close to 400, and very soon we will be, within this year only, we will be close to 500. And we are using 1080 UIC 60 kg head hardened rails. And practically our GMT as of now, even though it's a metro suburban traffic, it's around 60 to 80 annually, 60 to 80 tons annually. So that necessitates the requirement of grinding, which is on different lines, it is ranging from 6 months to 27 months. And both gauges are having operational challenges with respect to time available, with respect to the grinding requirements, with respect to the rail head defects generated, and the rail wear, and problem faced by rail wheel interactions. So, for controlling these issues, definitely rail grinding is a useful tool and which we have adopted. And we are also using rail grinding to control the noise and vibration generated due to the rail defects at many of the locations. And we are also undertaking a study to address the issue of rail longevity coupled with the rail vibration with the experience of rail grinding. So I'll be covering on these lines. One is the objective and the methodology of study, the wear behavior we have observed, the defect removal which we have carried out, the natural wear rate which has come or reduced as a process during process of rail grinding, the profile conformity, and the noise and vibration control used. A tool of rail grinding being used as a tool of noise and vibration control, and the further way forward. So objective of this study, or to be presenting in this paper, is to study rail behavior, to see the effectiveness of rail grinding and in defect removal and controlling noise and vibration and profile conformity. For this purpose, we have, we have established test sites at different locations, and these test sites are basically to monitor the surface control, and we are carrying out die penetration test, and we are also measuring the profile with mini probes. Yeah. So while measuring these profiles, over a, I think this, okay. The order is not correct. Anyway, something has gone wrong with the presentation. Anyway, I will cover, not an issue. There's one slide missing in the presentation. We have established, we are measuring results on the test site before establishment of test site, after the passage of grinding at test site, and after some passage, maybe about a year or maybe 6 months at those test sites. So we have observed wear with respect to the mini-prof, and the wear observed on various test site has been plotted, and we will see there are, I am presenting 2 test sites on broad gauge and 2 test sites on the standard gauge. And one of each is on sharp curve and one is on straight track, tangent track. So this UIC 77, which is shown in the slide, is on broad gauge sharp curve. You will see that the wear which we are measuring, the vertical wear rate is substantially high, whereas the wear on gauge face, the vertical wear is being presented in the blue line and the wear on gauge face is being shown in the orange line. So on broad gauge, you will see the wear at the sudden spike which you see on this slide is the grind cycle. So you see the wear rate after grind cycle in both the cases on broad gauge, on sharp curve has reduced. Second slide, second picture is on the tangent. There also the wear rate has reduced. On the standard gauge, the story is also similar, but here there is a very different phenomena that in case of tangent track, you see the gauge face wear is much lesser than the vertical wear. The orange line has come below the blue line. So these observations, which are very important, which has come that on curved section, the wear is concentrated on gauge face, which is attributable to the flange contact, because in standard gauge the flange contact is continuous. But on the tangent wear, on the tangent section wear behavior between standard gauge and vertical wear was, say in standard gauge, vertical wear is more prominent, and in broad gauge, gauge face wear is more prominent. Now you will see the wear in actual terms. On standard gauge, the reduction in wear on ULC we are saying it's the curved track, it has reduced substantially, but the vertical wear is very high. It is in the order of 3.3, and which has reduced substantially. Whereas on tangent, the wear is substantially low, but it has reduced considerably. See, this is the case of broad gauge. If we compare both these slides, in case of standard gauge, the vertical wear is lesser, and in case of broad gauge, the vertical wear is high. Similarly, if we compare with the standard gauge vertical wear and the reduction is very high in case of broad gauge. This is with respect to profile conformity. what we are doing, we are measuring post-grinding the profiles, and the profile observed by mini-probe is confirming the targeted profile. So we have experienced that the profiles are, the grinding is effective. Then some photograph at particular location where these are the defects which have been noted pre-grinding, and which has been, the photograph, the side, right side photograph is showing the defects which have been removed. Again, at one of the location, we have also recorded the vibration level, ground vibration level, pre-grinding stage and post-grinding. With effective grinding, the vibration level has reduced, which was 72 VDB average and 86 VDB maximum, which has been reduced to 70.6 and 77.2 VDB. This is specifically at the location where no vibration mitigation measures have been taken. Although there is a considerable reduction in vibration with respect to the grinding or by carrying out the grinding, but this study needs further elaboration, and we need to redesign we need to further augment our profiling with respect to the vibration control, so that it not only results in the wear reduction but also in the vibration mitigation. So this is the future strategy of DMRC, that we want to achieve rail wear, improve the rail longevity, as well as controlling the noise and vibration levels at the ground rail grinding locations. I think for this work, especially our partner, the agency who is doing the rail grinding works, Vandana International, and our team for getting this study successful implemented. Thank you.
Thank you, Mr. Khare. Now I'll request Mr. Goyal and Mr. Sapra to take over.
A very good afternoon to everybody. First of all, I am grateful to MD DFCCIL for giving us this opportunity to present this paper in this heavy haul seminar. It was the last minute entry, but he was kind enough to accept it. So we all know that track is very important, but the track has to be supported by structures like bridges also. And when we run the heavy haul, it is not only the rail which takes the wear and the burden, it is also the bridges who are subjected to heavier loads as compared to the normal loads. So DFCCIL is basically a new construction, but we are feeding the traffic to DFCC routes, and we are having the DFCC routes where we have to run the heavier axle load on the existing bridges. These old bridges were, some of them were built more than 100 years ago when the axle loads were too less, to that extent to 18-ton axle loads. And now we are having the axle loads up to 25 ton. So there is a concern of fatigue. The way we are concerned about the fatigue in rails, we take care of their testings, we do USFD testing, replace those rails, and there is a lay-down criteria of replacing rails after 800 GMTs. But somehow similar kind of attention has not been given to bridges probably, particularly the steel girder bridges, which are to be designed and maintained with respect to the phenomena of fatigue. So fatigue in bridges had been understood by the engineers earlier, but its effects were taken into account by reducing the permissible stresses. Whereas in 1980s, it was understood that this is not the correct way of taking into account the fatigue. The fatigue is governed basically by the stress range that is imparted on the connections. Not the absolute stress, but the stress ranges and their number of cycles that the components are subjected to in the service life, that is more important. So the efforts were made to revise the fatigue provisions, and finally in 2012, Indian Railway Steel Bridge Code got the modern provisions based on stress range concepts. But what about the existing bridges? They are to be assessed with respect to the new provisions. And we had been doing this exercise, and this particular bridge failure, as bridge number 57 in South Eastern Railway, has really awakened us to the realities, and we could validate our new codal provisions while analyzing this case study. So our team, including Mr. Manish, Director, RDSO, PED Infra RDSO, and myself, we had been thoroughly investigating this case, and we tried to project this case study here in this forum so that everybody is aware about these new challenges that are coming up in the field of heavy haul transport. So this is the bridge number 57. You can see it is a very long bridge having 7 spans of 300 feet and 2 spans on either side, 100 feet underslung girders. So it is situated on Kharagpur and Howrah. It is a DFC feeder route, having a GMT of about 80 to 85 annual GMT. And it has got 3 lines. The down line is the one where this failure has occurred. The middle line was constructed in 1928, and it is still having the same girders which were provided originally. The down line was having the original girders in 1900, but they were replaced in 1966. And the upline was constructed along with around the same year, 1966. So the girders of upline and the girders of downline, which was regirded, were of the same vintage. That is about 60 years ago, they were regirded or built. So these are the details. So important thing is the girders which were made in 1928, they did not fail. The girders which were replaced in 1966, they reported the failure. So this is an important revelation. And the design was done based on the BGML loading of 1941. At that time, the stress ratio concept was there. And the high-strength steel was used in the construction of these girders. And usually, people go for high-strength steel to reduce the weight of the structure and to bring the economy. But how much economy we have gained, that we will see now. And this design was based on the old fatigue provisions by reducing the permissible stresses, which was not the right way of doing it. This is the member section, particularly the one you see at the top, that is the vertical, which has actually failed. It's a very light section, simple section. And this is the vertical U1, M1, which you see encircled in red. This member actually failed. And all the verticals, whether it is U1, M1, U2, M2, U3, M3, they all were having the same cross-section. And the failure has occurred in U1, M1 because it was having, by design, the more stresses as compared to other members, whereas the same section was provided in rest of the other members also. This is the failure. You can see the complete failure, if I can have a indicator. Pointer, can I have a pointer? No. Yeah. You can see this fracture. This gap was 65 mm when this fracture occurred. And this has caused the complete tying arrangement of the top boom with the rest of the girder. And this top boom, which is usually in compression, always it is in compression, it was having an L upon R ratio, which has doubled after this fracture. So when the L upon R ratio doubled, this member was bound to buckle. So it buckled actually. And you can see because of the high stresses, compressive stresses, these members, they distorted. So with this distortion, the complete girder was basically become dysfunctional. And now it's a very important route, having GMT of about 80 We had to sustain the traffic. So it was a big challenge to control this girder and somehow make the traffic operational on this. And after this failure, the site was visited by our experts, including the RDSO people, and we have found that we have, initially we understood that it is a fatigue failure. And then we said, okay, if this is a fatigue failure, then we must examine all other verticals in rest of the other girders and in this girder also. So we did a thorough check of rest of the verticals of the same span and the remaining 13 spans also of the same vintage. And we have detected 27 more cracks in other verticals. So that that basically validated our conclusion that it is a fatigue failure, and this failure which has been detected now, is, if not detected, so it will have more failures in rest of the other girders also. So speed restrictions were imposed, and the train loads which were permitted, they were also reduced to sustain the traffic on this important route. You can see other cracks also. And then this was the arrangement, restoration for restoration. We somehow tied up all these members, did some kind of a, you can say, emergency repair. And now a reduced load of 20.32 ton with a speed restriction of 20 kmph is running on this girder bridge. And then at the same time, we have gone for a continuous health monitoring of this girder by engaging Structural Engineering Research Center, the most reliable agency available in this country for doing such kind of instrumentation, and now it is being monitored by them. So when we did the analysis of these failures, we have found the girder was commissioned in 1966. The original design, 1966 BGML loading, axle load had been raised from 22.32 tons to 22.9 ton at a speed of 40 kmph, and GMT was increased from 30 to 86.82. So basically, the members were subjected to heavier, rather larger sizes of stress ranges as compared to earlier one, and more number of cycles because of increased GMT. So that was the cause, prime cause of this failure. Then the vertical, I have told you, it was having the tension, and it was highest in the U1 M1. The same member has failed, which was having the highest tension. And the high strength steel was used, which actually reduced the help to reduce the section of the this vertical member. But the fatigue category, which has been specified in the Euro codes, and from there we have borrowed it in our IRS codes also, that doesn't depend upon the grade of the steel. So the grade of steel, they have reduced, they have increased, they have taken the higher permissible stress in the design, but it was not helpful, and that's why we have then restricted the use of higher grade of steel by issuing a correction slip in our bridge rule, so that no more new bridges are built with higher strength steel and cause a subsequent failure at a later stage. So we did the reverse analysis to find out what is the actually residual fatigue life of this member. If we do the reverse analysis by using the present day codal provisions, so what we have found, taking a detailed category of 80, if we do this exercise, this member at a average GMT of if we take average GMT of 30, then the residual fatigue life of this member was coming out to be 9.3 years. And for other members also we have calculated. So some of the members were having the residual fatigue life of more than 300 years. And the other M1, L2 member was also having a residual fatigue life of 11.39 years. U4H5, U5 was having a residual fatigue life of 16.78 years here. And this exercise was done with 25 ton loading at 125 kmph. But if we reduce the dynamic augment, instead of taking the speed of 125 kmph, if we take a speed of 60 kmph, this residual fatigue life figure that gets increased. For this member, it gets increased to 12.18 years. And again, we have to see that we have taken a detailed category of 80 MPa and a factor of safety, material partial factor of safety of 1.15. If we take this material factor of safety as 1, probably we can get more residual fatigue life. For a speed of 40 kmph, this life further gets extended to 13.27. Again, this is for 30 GMT. So these are the finally inferences drawn from this failure, that lower dynamic load are actually faced by this bridge as compared to the 25-ton loading which is actually running. And there were built-in redundancies which has helped to sustain this bridge for 60 years. Otherwise, it could have been failed in 30, 40 years. And pre-stressing concept in design. This is a very unique concept in our open web girder designs of RDSO, where we do the pre-stressing of the members. We provide reverse kind of stressing in all our members of the truss, so that theoretically they are neutralized at the time of actual loading. And we ignore their advantage. Then there are certain margins left, and there are certain factors of safety in design which has helped to this bridge to serve at least for this 60 years of life, actual life. And then good quality of fabrication. This girder was fabricated by BBJ, and the quality of construction was absolutely good. So seeing the quality of this fabrication, we could have probably taken the fatigue category 90 in the design. This bridge was also instrumented by Messrs. EMIL, and IIT Guwahati has examined their report. So there were deflections observed of the order of 30 mm, whereas they could have been 42 mm. So that less deflection was probably due to, again, redundancies in the structural arrangement. And finally, they said something about the fatigue, but they had not actually done the fatigue analysis of this bridge. So their report was not actually of any, drawing any conclusion. So this bridge has been subjected to excessive GMT and cycles of increased stress ranges, and fatigue life consumed much earlier than the expected design life, because it was not designed with respect to the modern concepts of design for fatigue. A section, although was safe as per the permissible stress consideration, but it was inadequate as per the latest provisions of fatigue assessment. So the recommendations are that the residual fatigue life for old steel bridges, which are more than 50 years, having GMT more than 40, should be assessed to plan strengthening regirdering based on the distress condition and the results of fatigue assessment. So we have already issued the instruction in this regard from Railway Board in the month of May and June 2024. And then some correction slips have been issued in the bridge manual for periodical assessment of old steel girder bridges, which are having GMT more than 40 and age above 50 years. And the restrictions of loading of speed or both shall be imposed as per these correction slips. This has been made part of the manual so that the people do not get any resistance from the operating department. And then ultrasonic flood detection, acoustic emission technique, and other oscillation measurements, etc., may be carried out for determining the proper scheme of instrumentation in consultation with RDSO. So a phased-wise assessment program has been suggested in the, again, IR Indian Railway Bridge Manual. In phase 1, preliminary evaluation based on the documents only, and detailed investigations by refining the parameters like GMT, actual GMT, what is there, what is the actual speed. All those parameters are to be assessed more realistically, and then again analysis, and if the structure is still found to have less fatigue life, residual fatigue life, then we have to go for expert investigation who will do the instrumentation for a period of say 15 days or 1 month, the representative period of the year, and then make the actual time histories and histogram, stress range histograms to work out the detailed fatigue assessment of different members and work out the residual fatigue life. And even if the structure is not found safe, then the phase 4 is to take remedial measures, like you have to plan for replacement, intensify monitoring, and you have to impose all kinds of restrictions, and then sustain the bridge somehow till the new bridge comes up. So this is the approach for residual fatigue life. Fatigue control options, this I have already told. And instrumentation monitoring, there has been a guideline issued by RDSO, which is to be followed. And now we are also looking for a technology which is called alternate current field measurement technology, ACFM technology, wherein one can detect a eminent fatigue crack emanating from the bolt hole without removing the paint from the connection. So we are trying to develop the vendors for this technology. Once that is done, we would be in a better position to assess the health of all such members which are found fatigue critical. Thank you very much. I was told to complete it in 10 minutes, so I hope I have complied. Thank you.
Thank you, Mr. Goyal. With this, we have come to the end of this session. There are a few questions, not much, 2-3 questions. One is from Mr. Khare, one is from Mr. Goyal, and one is for Mr. Saxena. So I'll request Mr. Khare to answer the question.
Yeah. There is a question from Mr. Arun Tiwari, DFCCIL. In DFC, short dense RCF are being observed on the surface of 1080 head hardened rail, whereas an 880 grade rail is extensively long scattered RCF cracks at nearly same, I think it's not very clear, same location probably. What pattern is being observed in DMRC stack? Actually, for DMRC, the observance of RCF is not very important because the axle load in any metro transport authority is around 16 to 18 tons and we have 17 tons. So the RCF per se is not very troublesome for us, but we are trying to eliminate the surface defects. We are trying to use the grinding for controlling corrugations, controlling noise and vibration. In fact, on DMRC, even after 20 years of service, there is no rail fracture which has occurred due to RCF. So, but since I have the experience of DFCC also, then probably the 1080 HH rail, that's in Western DFCC, is the different one. And the geometry, the percentage of curved length, the continuity of curved length versus straight lengths, that is probably giving this difference which you have observed in Eastern and Western DFCCIL. And the second question, what all measures and mitigations you have taken in the existing tunnels facing vibrations to the above building, Force, Airport, Express Line and Yellow Line in Delhi, what are future plans? This is from Mr. Ashish Arora, vibration experts. Actually, in DMRC, due to legacy in phase 1, we have not adopted any mitigation measures in the underground section, that is the tunnel. And the attention to controlling ground vibration felt in the nearby buildings was not to the desired level. But from phase 2 onwards, we have started taking all mitigation measures, and from phase 3 and phase 4, we have further strengthened our monitoring mechanism, and we have started taking the measures well in advance, and that too more, I'll say, adequate measures to control noise and vibration felt in the nearby buildings. The yellow line which you are talking about is the older one, the Airport Express line, there the speed is more. So what is happening that with the standard MSS, the standard mitigation measures, there is very less probability of repairing or rehabilitating or retrofitment in the provided MSS or provided mitigation measures. So the only alternative is either to control through rail surface, that's the grinding and milling, whatever is required, or try some mitigation with the help of improvement in the stiffness, or rather I'll say manipulating the stiffness in the fastening level. So this is the only alternative to control the legacy track which we have laid. And of course, the recent technology has also come up by installing tuned mass dampers on the rail face, on the rail webs, which can further control the natural frequency of vibration generation. So that is also being tried. So both the measures are being tried extensively to control on yellow lines and express lines.
Thank you, Mr. Khare. I'll request Mr. Saxena to answer the question.
This is a question from Shri S.K. Suri. The question reads as, to what extent is DFC planning to go in for heavy haul operation on DFC? So we are already capable of running 25-ton axle load, which is the highest load available in the country. We are already running sections up to 100 GMT on some of stretches. And given a choice, we would like to run all loaded trains, no empty train at all. Thank you.
Thank you, Mr. Saxena. I'll request Mr. Goel.
This question is from Mr. Ashish Bansal. There are three questions actually. First question is, which is the oldest steel girder bridge on Indian Railway, which is being sustained by railways despite of increased axle loads? So, which I am able to recall is the Kashi Bridge near Varanasi. It is already 135 years old and now it has been sanctioned for rebuilding. So the natural question would be how we are able to sustain this bridge for 135 years. So the answer, I am just giving you one more dimension of this thing. Actually, if you see the Kashi Bridge, there is a speed restriction of about 20 kmph on this bridge. First thing. Then second thing is, this is a rail cum road bridge. The total load on the bridge, the dead load of the bridge, is comprising the dead load of the road deck over the second floor, you can say. So the composition of dynamic component is comparatively less as compared to the overall load. So it is facing the fatigue, but to a lesser extent. So because of the low speed and the heavy dead load, the fatigue effects are not that critical in this bridge. So we are able to sustain it, and it will be sustained for at least 5 to 10 years more, because the new bridge construction will also take some time. Then second question is, how do you deal with the girders which are found susceptible to fatigue failure? Actually, right now, we do the academic exercise based on the documents to work out what are the bridges which are which have already exhausted their residual fatigue life. So our new bridge code, IRS codal provisions on fatigue, they allow us to do the reverse kind of a calculation to work out what is the residual fatigue life of different components, and we work out the minimum life of any member, and that is treated as the residual fatigue life of the bridge. And then we do the extensive monitoring. We go for detailed analysis by defining the input parameters, and then if necessary we go for a third-party audit and instrumentation who work out the detailed fatigue life analysis, and even if the life is not found sufficient, then we impose the severe restrictions. That is the mandate given by the Indian Railway Bridge Manual. And then what are the innovations expected from the industry? I think this is very important. We need the support of the industry to help us to find out what are the techniques to detect the imminent fatigue cracks in the connections. We are having riveted connection in all the old bridges. So if some technology can help us to detect the imminent fatigue cracks, probably we can allow the traffic without any restriction till such time the warning is given by this technology. Thank you.
Thank you, Mr. Goel. With this, we have come to the end of this session, and I hope All the delegates here would have been benefited by the information and insight given by the speakers. Thank you. Thank you very much.
Sincere thanks to all the presenters for their valuable insights and engagement. These discussions offer a promising path towards a safer, more resilient and cost-effective rail networks. It is time that we present mementos, the symbols of respect and honor, as well as lasting memory to each of our speakers. May I please request Shri Praveen Kumarji to present these tokens of appreciation and respect for our speakers. We begin with Shri Pankaj Saxena ji. Shri Atul Khareji, thank you very much for sharing your perspectives, your knowledge, your views with all of us. Thank you very much for joining us here in this session. The Statue of Unity, symbol of national unity and pride, and also a seminar memento. Shri R.K. Goyalji, thank you very much for joining us here in this discussion and sharing your thoughts with all of us. Thank you very much. Symbol of respect and honor, as well as lasting memory of this seminar. Shri S.K. Sapraji, the co-author of this paper. And the moderator, Shri Mahesh Gupta ji. Thank you very much. These definitely serve as lasting memory from the Global Heavy Haul Seminar 2025, the Statue of Unity followed by the seminar memento. This is for all our esteemed speakers who shared their knowledge with all of us and enlightened with all the ideas that they had. Thank you very much. So before we request Shri Praveen Kumarji for presenting a summary of these 2 days of Global Heavy Haul Seminar and also the recommendations by DFCCIL, may I first request Ms. Carrie Gonzalez, Chairperson, International Heavy Haul Association, to please present her closing remarks, please.
Perfect, thank you. Over the past 2 days, we've explored the powerful intersection of leadership, strategy, and innovation. 3 pillars that are not just guiding principles, but imperatives for progress in our industry. Leadership is about vision and courage, the ability to navigate complexity and inspire collective action. Over the past 2 days, we've seen how strong leadership is transforming infrastructure, operations, and policy across continents. Strategy is our compass. In a world of shifting demands and rapid change, strategic thinking enables us to align our resources, anticipate challenges, and seize opportunities that drive long-term value. And innovation, the engine of our evolution. It's redefining what's possible, from new maintenance strategies and AI-driven logistics to sustainable freight corridors. Innovation is not just enhancing performance, it's reshaping the very fabric of heavy haul transport. This seminar has reaffirmed that when we come together across borders, sectors, and disciplines, we unlock the potential to build a more resilient, efficient, and sustainable global freight ecosystem. Let us carry forward the momentum, the ideas, and the partnerships we've forged here today. And the future of heavy haul is not just being imagined, it's being built, and each one of us has a role to play. Thank you once again to DFCCIL for hosting this visionary platform, and to all of you for contributing to its success. I would also like to extend my gratitude to Mr. Sagal and the LORAM team for encouraging my attendance and your gracious hosting during my time in India. I wish all of you future success, and I look forward to forging more partnerships to shape the future of the Indian railway system. Let's keep moving forward together. Thank you.
Let's carry forward this momentum and all the ideas that we discussed over these 2 days. Thank you very much, Ms. Kerry Gonzalez, for that wonderful remark from your side. Ladies and gentlemen, we will now request Shri Praveen Kumarji, MD DFCCIL, for presenting a summary of these 2 days and also the recommendations by DFCCIL. Sir, Shri Praveen Kumarji.
Thank you, Juhi. Good afternoon to all of you. Distinguished delegates, esteemed speakers, colleagues, partners, and friends. As we bring the curtain down on the Global Heavy Haul Seminar 2025, I would like to express my heartfelt thanks and reflect on how truly impactful and inspiring these 2 days have been. Displaying the long-term vision of Ministry of Railway and DFC, this seminar has set new benchmarks for collaboration, innovation, and knowledge exchange in the field of predictive maintenance for a sustainable heavy haul operations. We at DFCCIL are honored to have facilitated this confluence of ideas. It has been our mission to not just build world-class freight corridors, but to create platforms like this that advance learning and know-how. In this endeavor, I would like to thank our incredible speakers, panelists, moderators, and all the supporting staff and everybody who has been associated with this Global Heavy Haul Seminar. And I thank all of you. I also thank our international delegates. Thank you for traveling all the way to deliver your expertise on the subjects in this conference. Your presence has enriched the seminar beyond measure. I would also like to specially mention our mentors and advisors, Sri Subodh Jain, Mr. Chaudhary, Mr. Lalwani, Mr. Deepak Krishan, Mr. Mahesh Gupta, Mr. Vijay Sharma, and many other officials who have contributed by speaking very in-depth questions from the delegates, from the experts. I welcome and acknowledge their presence in this heavy haul conference. And I also acknowledge their guidance and their active involvement as moderators and in these sessions. Your technical experience and deep understanding of the subject has enriched this seminar. This seminar was a team endeavor, and it could not be a success without the support of our sponsors, various sponsors like Vandana International, Gartner, Rahi, Voltas, Plaza India, Weekend, Messrs. M Fiber, Hitachi, Oberoi Thermit, and many others. I extend my gratitude to Railway Board for the vision, direction, and their unstinting support, without which this event would not have been possible. I thank all the media partners for wonderful coverage of this seminar. I also acknowledge the support given by Bharat Mandapam officials and their supporting staff. I acknowledge with the humility the hard work given by our organizing team in meticulous planning and tirelessly working round the clock for the execution of this seminar. I thank each and every behind-the-scene worker who worked to make this event a success. Before we leave, let me close with an announcement. Encouraged by the success of this seminar, DFC has decided to host such seminar on biennial basis in future as well. The next seminar would be held during February 27 here at Delhi, maybe in the same venue. And the topic of the seminar would be digital twins to dynamic tracks, reinventing infrastructure maintenance in the age of artificial intelligence. The focus would be an application of digital twins, real-time modeling, and AI-based prediction tools to monitor, simulate, and maintain railway infrastructure efficiently. Let us build on the partnership we have formed and translates all these things ideas into action. While welcoming you all to the DFC Corporate Office and Heavy Haul Institute, I would not bid adieu, but rather say let us temporarily part physically while remaining firmly connected to further our collaborative setup initiated here till we meet again in New Delhi in February 2027. Thank you and Jai Hind.
What lies ahead? Taking on these learnings and building on the work that has already been done. What we discussed in these 2 days are not just systems and strategies, they are in fact the blueprints for tomorrow. As we draw the curtain on this enriching journey, let's remember, innovation may begin in seminars and workshops, but it thrives in collaboration and shared vision. We thank you very much for being a part of this Global Heavy Haul Seminar 2025. We will now disperse for lunch, and then all those who have given their names for DFCCIL corporate headquarters and HHI office visit may assemble at 2:45 p.m., that is 14:45 hours, near the porch area for bus facility that has been arranged for this. And for all others who wish to travel by their own vehicle may follow the bus. Thank you once again, ladies and gentlemen. I'm Juhi Malhotra signing off. A big thank you to everyone for joining us here. Thank you.